Welcome to this free Rhino Beginners course. This is a fully comprehensive 6.5-hour tutorial where you will be learning all the basics and tools. If you would like to learn everything there is to know about using Rhino like a pro, check out skillademia.com and get access to the full course. Without further ado, let's get started.
Hello, I'm Joyce Kubrisi and I will be helping you become experts in Rhino. Before we start anything related to this course, we should start at first by understanding what is Rhino. Rhino is an easy model making software which allows you to create any shape that comes to your mind with precision and detail, whether it's originating from an image, sketch, drawing, or a 2D, 3D scan. Who uses Rhino? Rhino is used by engineers such as civil engineers, mechanical engineers, industrial engineers, or even architects, as well as designers such as jewelry designers, product designers, or interior designers. Not to forget, anyone who is interested in creating 3D models can learn this software, regardless the background or profession. So let's start with the Rhino basics. The first thing to do is to download the software from the Rhino website. You could see the link on the screen right now. After you download the software, you should launch it. I will be using the Rhino 6 version. It's very similar to the Rhino 5, so it's okay if you're using Rhino 5, Rhino 6, and also the settings are applicable for the Rhino 7 version. When you open Rhino, the first thing that will pop up is the welcome screen. You will see at first all the recent Rhino files that you had worked on in the past. You could continue working on them or just create a new Rhino file by clicking on the New tab. When you click on the New tab, you will see a list of objects stating the scale of the model you want to work with, as well as the units that you will be working on. So, for example, I want to work with, I want to do a small object and I want to work with meters. So I click this one and I will be accessed to the Rhino. At the top left corner, we have a ribbon. It's called the window title, and it usually displays the model's file name and file size. And by default, right now it's called undefined. The first thing to do is to rename the file. You should click on File, Save As, name the file's name. I will name it Tutorial 1 and click Save. And as you can see, the name of the file changed to Tutorial 1 and this is the file size. The second thing that you have to know about Rhino that it is made up of 4 main components: curves, surfaces, solids, and meshes. And every single 3D will be based on these components. And where could we find them? The answer is in the second ribbon where the file edit view are present. So it's named the menu tab or the menu ribbon. And the purpose of this menu is to group the tools by function. So you could find anything related to curves under the curve section, or anything related to surfaces under the surfaces section, anything related to solid under the solid section, the mesh. So it's basically a guide for you to select anything you want. So basically all the Rhino program is based in this menu. As you can see, you have the help. If you are stuck in anything, it could help you. If you want to render later on, you could use this. So every single thing or tool is present here. The third thing you have to know about Rhino is that Rhino is a command-based software, which means that you give the software an order of what you want to do or draw through a command. And the command prompt, where the word command is present, you could type any command you want or any order you want to do, and the software will do it. For example, if you want to draw a line, all you have to do is to type line in the command prompt and select it or enter. And you'll have like some options here of what do you want the line to have options. If you don't want anything, you just don't click anything and you start drawing a line. If you want a rectangle, you just type the command of rectangle, enter, and the software analyzes what you want and gives it to you. Here's the rectangle. So this is what is a command prompt is. So we draw like a line and the rectangle, and so we created a history of commands. So the history of commands are present in the command window, which is here. So as you can see that one curve was added to the selection because I selected it. Let's go back. We chose a corner of the rectangle. We started a line. We created a file. So this is basically the history of what I did from the beginning till the recent command I did. And this is present in the command window. So in this lesson, we learned how to name a file, the menu tab, the command prompt, and the command window. In this video, I will be introducing Viewport. The first thing that you see when you open a Rhino file is 4 rectangles. Rectangle 1, Rectangle 2, Rectangle 3, and Rectangle 4. And each rectangle is made up of squares in it, as you can see. And the area that is holding all the rectangles is called the graphic area. This is the graphic area. And each rectangle inside the graphic area is called the viewport. So we have 1, 2, 3, 4. We have 4 viewports. The viewport has a job, and it is to display the views of the model within the graphic area. And by default, the 4 views that are displayed are the top view, the perspective view, the front view, and the right view. Each viewport can be customized to suit your preference. For example, let's work with this viewport. I want to resize it. So what I will do is that I would click and drag the side of the viewport. So as you can see, it's enlarged from this side. I'll do the same thing for the other side. So I would click and drag downwards. And as you can see, this viewport is now larger than the other viewports. Let's return them to the initial position. The viewports can also be relocated. So to do that, you should click on the title and drag it. So I'm dragging it to the middle right now. Let's resize it from all sides. If you want to return it to the initial position, all you have to do is to click and drag it to the position and adjust the corner. The viewports can also be renamed. You can also add a viewport to the graphic area, a new viewport, and you can close or delete a viewport. The viewports present here are independent of each other. So they are not linked to each other. If you move in one viewport, nothing will happen to the other viewports. Let's try other viewports. If you move here, nothing will happen here. If you try to move here, nothing's happening here. And if you try to move this one, nothing happens here. So At the bottom left of each viewport, there is this axis symbol, and it's called the world axis icon, and it is present to determine the position of the model. And as you know, any object has axes, and every 3D model has 3 axes. For example, this rectangular prism has a y-axis, has an x-axis, and has a z-axis. And those axes represent the length, width, and height or depth of the model or the rectangular prism, respectively. So let's return to the viewports, and I think you are curious about those squares and what do they do. This is basically a grid, and a grid is a network of lines that cross each other in order to form a series of squares. And those squares are usually used as reference for measuring. As you can see, it's made up of big squares, and those big squares are made up of small squares. The grid also has an x-axis and a y-axis, and those axes are mainly for the grid. And the intersection of these axes is the 0.0 reference. So if you want your model to have a reference point, you can put it on the 0, reference, and your model will start at this point. In the previous video, I started the measuring unit in meters. And as you can see in the window title, the name of the file is tutorial 1. So it's the same file that I used in the previous video. So the unit that I'm using right now is meters. So since I'm using the meter unit, so each small square has a dimension of 1 meter. So the side of the big square is 5 meters. So because it's made up of 5 squares. If I want to change the unit, for example, from meters to centimeters, what should I do? So you type options, you click enter, and you will be directed to the Rhino options window. You search for units, and as you can see, the model unit is in meter. You select the list, and you can choose any unit you want. There is a variety of units, so I will choose the centimeters. You click enter, or you click OK. And what will happen is that the small unit that was 1 meter now had become 1 centimeter. So from here to here, it's 1 centimeter. And the side of the big square is now 5 centimeter. So if you have like a rectangle here, the side of the rectangle is 5 centimeter by 5 centimeters. So basically, this is the video 2. And in this video, we had learned that an introduction of the viewport, what is a grid, what is the unit, and how to change from unit to another unit. And in the other video, we will continue working on the viewports. We'll see more settings, and that's it. In the previous video, I introduced what is a viewport and what is its function. In this video, I will be continuing everything related to viewports. Let's start by understanding what's the meaning of views. Each object has 6 views. For example, let's take this camera. This camera at this moment is in the perspective view, where you can see the object in a 3D view. The top view of the object is how you see the object from the top. The front view of the object is how you see the object from the front. The back view of the object is how you see the object from the back. The left view and the right view is how you see the object from the sides. And the bottom view is how you see the object from the bottom. Returning to the viewport, as you can see in the window title, this is the same file used in the previous videos, but I want to work on a new existing Rhino file. So what I would do is that I would go to the menu tab, select File, click on Open. So I will be choosing Tutorial 2 file. I would double click on it and it would open. As you can see, there's a geometrical shape set present in all viewports. In the top viewport, we can see the shapes from the top. In the perspective viewport, we can see the objects as 3D, or in a perspective view, in the front viewport, we can see the objects from the front, and the right viewport, we can see the objects from the right side. But what about the other views? How can you shift views if you want to see, for example, the back view? All you have to do is to choose a viewport. For example, I would choose the top viewport by clicking on it and clicking on the arrow of this viewport next to the top title, and a list will appear. You search for set view and a list of views will appear. So you choose any view you want. I want the back view. And as you can see, the top viewport was replaced by the back viewport. And as you can see, the changes happened in this viewport only because, as we said before, the viewports are not related to each other. And if you want to change the views in the other viewports, you have to do the same thing. You should click on the viewport, click on the arrow, click on the arrow and select the view and choose any view you want to replace. As we mentioned before, the viewports can be adjusted to suit your preference. And how you adjust the viewports in the graphic area is called layouting. So in the layouting, you can add viewports, you can split one viewport into two viewports, you could delete a viewport. So how to do this is you have to select the viewport that you want to adjust. For example, let's choose the perspective viewport. You click on the arrow of this viewport and you go to viewport layout because you want to adjust the layout of the viewport. As you can see, there is a new viewport, float viewport, hide viewport tabs, split horizontal, split vertical, 4 viewports and 3 viewports. Let's start, for example, by splitting this perspective viewport horizontally. We click on it, and as you can see, one viewport became 2 identical viewports horizontally. Let's split, for example, the front viewport vertically. So all we have to do is to click on the viewport, click on the arrow, search for viewport layout and split vertically. So as you can see now, it's split vertically. We have 2 identical viewports in the previous front viewport. Now, for example, I don't want this viewport, this new viewport. So what I would do is that I would click on the arrow of this viewport, and as you can see, these 2 viewports are also independent of each other. So each one has its own arrow. So what I would do is that I would click on the arrow and I would choose close viewport. As you can see, it disappeared, but there's a black window. So what I would do is that I would click and drag the other one. So as you can see, it returned to its initial position. Let's do the same in this one. So I want to close this one. So what I would do is that I would click the arrow of this viewport and choose close viewport. As you can see, this is the black zone. What I would do to remove this black zone is to click and drag the one. And as you can see, it returned to its initial state. Now I want to add a viewport. As you can see, I should click one of the viewports. Let's continue with the perspective viewport. We click on the arrow, we go to the viewport layout. As you can see, there is something called new viewport. I would click on it, and as you can see, a new viewport just appeared on the screen. We could change it into, for example, the bottom viewport. Now it's called the bottom, so we have the back perspective, front, and the right perspective. If you don't want this anymore, you click on this viewport, on the arrow, and close viewport. As you noticed, the geometrical shapes are in form of lines. This is called the wireframe mode. In order to change how you see those geometrical shapes, you have to select the viewport that you want to see the changes in. Let's continue in the perspective viewport. We select it and we click on the arrow. As you can see, now it's selected. The wireframe is selected. So those are the modes, how you see the objects. Let's try the shaded one. As you can see, the shapes now have colors. Let's try the rendered. The rendered is used to see the textures and material used in the shapes. For example, if you want to put wood or steel or glass, those materials will appear in the rendered view or the rendered mode. Let's try the ghosted. The ghosted has colors but also has a bit of transparency, so you could see through this rectangular prism. You could see the cone, and you can see also the ellipse, the sphere. Let's try X-ray. X-ray is somehow similar to the ghosted part, but what you see is the wireframe of the cone. You don't see it as a whole solid. You see the wireframe of it. You see the lines. The technical part, you see the complete line and you see the dashed lines too. So everything dashed is the hidden part, and everything whole line is the scene part. Let's try the artistic mode. In the artistic mode, you see the object as sketchy, as an artistic way. In the pen view, you see the object as drawn in pen or a pencil, like drawing. You choose any mode you want. Let's keep the shaded part, for example. And as you can see, only the changes are happening in the perspective view because I chose to work in the perspective view. If I want to work in the back viewport, I have to do the same thing. Let's click on shaded. Now you can see the object colored. Let's put here the pen. You can see them in pen. Let's put here rendered. You can see them in the rendered view. I'll pass to the viewport tab, which is present here, and the main job of the viewport tab is to make your layouting process easier. So if you want to select a viewport, all you have to do is to select on the name. For example, I want to select the perspective viewport. All I have to do is to click on it, and as you can see, the perspective title became blue. And everything blue means that you have selected this viewport. Let's select, for example, the back viewport. As you can see, this one returned white and this one became blue. So the selected viewport is this one. If you want to rename a viewport, all you have to do is to double click on the tab that you want to rename it. For example, I want to rename this back viewport. I'll double click on it and rename it. For example, I want to rename it the back viewport. I click enter, and as you can see now, the name has changed into back viewport. If you want to add a new viewport, but you don't want this viewport to appear in this graphic area, you want it to appear like separately, all you have to do is to click on plus sign and click on new layout. New layout setting will appear. You just have to give the layout, the viewport, a name. For example, let's name it bottom viewport. You select the measurements that you need this viewport to have, and you click OK. Now you can see that you have the own viewport of this bottom viewport separately from the other four. And if you want to go back to the 4 viewports, all you have to do is to click on any of the perspective, back view, front view, or right view, and you'll go back here. If you want the new one, you just click on this one and it will appear on its own. You can also import a new layout by clicking the plus sign. If you want to remove this viewport, all you have to do is to right click on this tab and select the delete. You want to permanently delete this layout. You click on yes, and you can see it's deleted. So basically, this is everything related to the viewports. In this video, I will discuss how to navigate in Rhino. In order to work in this software, you should use the keyboard and the mouse. At this moment, I will be talking about the mouse use. If you want to select or choose anything in Rhino from options, settings, tabs, toolbars, or if you want to drag or choose a viewport, you use the left click of the mouse. For example, if you want to choose a viewport, let's say I want to choose the perspective viewport. What I would do is that I would move the cursor of the mouse and left click on the perspective viewport. And as you can see, this viewport is now selected because the title turned blue. The same goes for anything in Rhino. Let's take another example. Let's say I want to choose the dimension tab from the menu tab. I would go to the dimension and I would left click on it, and the list of everything related to dimensions appears. If I want to choose, for example, any option from this list, I should also left click the option. And the command is ready to be started. If you want to initiate any command and if you want to end any command, you should also left click. For example, I want to start this command at this point, I should left click on this point. If I want to end this command at this point, I should left click on this point. And as you can see, the command of the dimension is ready to be seen, but it's still moving. In order to stabilize any command, you should also left click. And as you can see now, it's stable at its place and it's not moving. In order to zoom in and zoom out using the mouse, you should use the mouse wheel. First of all, you should choose the viewport that you want to zoom in and zoom out in. Let's say I am choosing the perspective viewport. All you have to do is to slide your fingers upwards on the mouse wheel, and this would zoom in the viewport. And if you want to zoom out, you should slide your fingers downwards on the mouse wheel. So now, as you can see, it's zooming out, and the zooming in, zooming out action is happening in the viewport that I selected, because as we said before that the viewports are not linked to each other, so each one has its own function. Now in the perspective viewport, if you keep your fingers pressed on the right click and you move your mouse, rotation will take place. As you can see, the grid is rotating and the objects are rotating too. But if you long press on the other viewports, panning will happen, rotation will not happen. If you long press the right click of the mouse in this viewport, for example, and move the mouse, rotation will not happen. The same happens here. Because the perspective viewport deals with the object as 3Ds. So there is an X, Y, and Z. While in the other viewports, the objects are seen as 2D objects. So there is only two axes, like X and Y, or X and Z, or Y and Z. So rotation is impossible in a 2D surrounding or in a 2D workspace. Now, if you want to pan in the perspective view and not rotate, what should you do? While pressing on the right click of the mouse, you should apply also the shift. Now you can see the grid is panning and it's not rotating. Another feature of the right click of the mouse is when you click it once, the last command that you entered will restart. So in order not to write this command again, in order to insert it and reuse it again, you could press on the right click of the mouse and the last command that you use will restart, and you could reuse it again. So basically this is everything about the mouse use. In this video, we will deal with everything related to the object in the viewport. You will learn how to select an object, how to move an object, how to delete an object, and how to copy an object. In the previous video, we said that everything related to selection happens with the mouse click. For example, anything or any object that you want to select, you have to move the mouse to this object and you have to left click this object. If I want to select this sphere, for example, I have to move the mouse or the cursor to the sphere and left click on it. As you can see, the sphere turns yellow, and every object that is yellow inside the viewport means that it is selected. Now let's select, for example, the cone. As you can see, the sphere is not selected anymore and the cone turns yellow. This is because per one click, one object can be selected. But if I want to add the spheres to the selection, all I have to do is to press Shift and then press on the sphere. Now you can see that the cone and the sphere are now selected. If I want to deselect, for example, the cone, I would click the Ctrl and left click on the cone. As you can see, the cone is not yellow anymore, so that means that the cone is not selected anymore. Only the selected object is the sphere. Now, if I want to deselect all the objects inside this viewport, all I have to do is to click anywhere outside those objects and everything will be deselected. If I want to select like the sphere and the cone at the same time, all I have to do is long press the left click of the mouse outside and I would drag it to reach the object that I want to select. For example, here the cone and the sphere are included inside the selection square. And I would release the left click. As you can see that the sphere and the cone are selected. If I want to add the rectangular prism, I click on Shift and I would left click the rectangular prism and those are selected. Let's move to the moving of the objects. Let's say I want to move the sphere to this location. All I have to do is to select the sphere and long press the left click of the mouse and drag the object. If I want to put it here, I would release the left click. And as you can see, the sphere is relocated to this position. If I want to move the cone here, I would select the cone. I would long press the left click and I would drag the cone to this location and I would release the left click. And as you noticed, the moving is occurring in all the viewports because we are dealing with the object. If we want to delete an object, for example, we want to delete this prism. We select this prism and on the keyboard we press the delete button and the prism will be deleted. And if we want to copy, for example, this rectangular prism, all we have to do is to select this rectangular prism and go to the menu tab, click on Transform and choose the copy option. A blue point will appear. This blue point means that I have to choose a reference for copying. For example, if I choose this corner of the rectangular prism, this means that the copying process would start from this point. So all I have to do is to left click and drag the new rectangular prism to the new area. For example, I want this rectangular prism to be copied here. So what I would do is that I would press on the left click of the mouse. And as you can see, the rectangular prism is copied here. I could do the same procedure everywhere in this viewport. And if I want to stop this action from happening, all I have to do is to click on the right click of the mouse and the copying process will stop. Now, if I want to delete, for example, those two, I would select them and press the delete in the keyboard. And this is how we delete. So we learned how to select an object, move an object, delete an object, and copy an object in this video. So this is the end of the video. Thank you for watching, and please make sure to continue watching the next chapters in order for you to become experts in Rhino. In the previous videos, I did a brief introduction about the Rhino software, where we learned the basic components of Rhino. In this video, I will be starting with the toolbars and basic tools. Let's start with the curves. What is a curve? A curve is formed of two or more points joined together in order to form a line. A curve can be a straight line or a curved line, depending on the number and location of the points forming this line. In Rhino, there's a set of buttons present on the left side of the screen. This is called the toolbar. This toolbar is used for constructing anything in Rhino, and the upper buttons present in this toolbar are used for constructing curves. So if you are constructing any curve, you use those buttons, or you can go to the tab menu, to the menu tab, and click on curves, choose the command that you want, and start working with curves. Now, if you point the cursor of the mouse on the buttons, you can see that there are labels. This is because Rhino is a guided software, so everything is labeled in order for you to understand each command and help you choose the most suitable one. Next to each button, there's an arrow. This arrow is responsible for giving you more options and commands related to this button. It's like a subcategory for each button. So as you can see, each button has this arrow, which gives you more options. So let's start with the buttons. The first button that I will be introducing is the polyline button. But what is a polyline and what is the difference between a line and a polyline? A line is when you join only 2 points. For example, we have point A, point B, they are connected together, so this is a line. Whereas a polyline is when you join a set of lines together in order to form a bigger line. For example, we have this bigger line and it's formed by line 1, line 2, and line 3. Now, if you want to create a polyline inside Rhino, all you have to do is to point the cursor on the polyline button, see the instructions. For example, if you want to create a polyline, you should left-click the mouse. Once you left-click, the second step that you should do is that you have to see the command prompt for further instructions. For example, now inside the command prompt, they are telling us where we want to start this polyline. So we should pick a point, a starting point. Let's say this is the starting point. We have to look back at the command prompt to see what's next. So they are asking us to choose a next point for the polyline. So we have to choose another point. We keep on choosing points until we reach the final design that we need. And if we want this line to be a straight line, all you have to do is to keep on pressing the shift. As you can see, it's moving in a straight direction. And if you don't want this feature, all you have to do is not click on the shift button and it becomes free. Now let's say our design is finalized. So all you have to do is to press the enter if you're done, or the space button, or the right click of the mouse in order to terminate the polyline. Now let's try the other option, which is the line segment. All we have to do is to right click the mouse. They are also telling us to start the line. So let's draw the same design. Now, what's the difference between a polyline and a line segment? If we select the polyline, all the lines will be selected at once. But if we select the line segment, each line will be selected alone. So the line segment is a detached polyline, whereas the polyline is have attached lines, while in the polyline it is attached. Now let's start experimenting other commands inside the polyline button by clicking this arrow. As you can see, the list appeared, and for example, let's choose the first button, which is the single line. In order to choose this single line, you should left click on the mouse. And before starting anything in the command, you should look at the command prompt to take the instructions. They are telling us also to choose a starting point for the line. Let's choose this point, for example, and they are telling us to end this line at a certain point. Now, as you can see, the command has stopped because this is a single line, which is joining 2 points together. This is the difference between a line and a polyline. Now, let's restart this command. You can restart it either by clicking the right click of the mouse or by re-entering the button. Now, as you can see, there is also other options inside the command prompt. And the first letter, as you can see, it's underlined. So in order, if you want to have other options related to this line, all you have to do is to write the first letter. For example, I want this line to be angled. All you have to do is to type A and enter. Now in the command prompt, they are telling you further instructions. So they want us to start a baseline. Let's say this is the baseline. They are telling us to write an angle. Let's say I want this line to be inclined 25 degrees. I press enter. And now, as you can see, the line is inclined 25 degrees. Now, I should enter the end of line point. And now, as you can see, our line is inclined 25 degrees from the baseline, the imaginary baseline that we stated before. Let's try another command under the polyline button. So we tried the single line button. We tried the polyline button since it's the same as the one present outside. So let's try the line from midpoint. And this is used in order to create a line having its midpoint as a starting point. So let's click on this button. And as you can see, it is telling us to choose the middle of the line as a starting point for this line. So if we choose this point, we can see that the midpoint is pinned and the line is being constructed with respect to this midpoint. So we can say that this line is created by the midpoint being the starting point of this line. Let's try the line from 4 points. Rhino is telling us to start the baseline. And the baseline is an imaginary reference to start a line. So if we start this baseline at this point and we end it at this point, then they will tell us to start the starting point of the line. So we can choose, for example, this point and the end point. As you can see, the baseline disappeared and the starting point of this line is the end point of the baseline. Let's try the bisector button. But first, what is a bisector? A bisector, by definition, is a line passing through the midpoint of an angle. So this is an angle and this is the bisector which is passing through the midpoint of this angle. So in Rhino, they are telling us to start the bisector line. And as you can see, an angle is being formed. And there is like a midpoint line, which is the bisector, forming two. If we click on the left click of the mouse, the angle will disappear and the only remaining part is the bisector, because this is what is needed to be drawn. So all you have to do now is to click on the left click in order to set the end of the line. And as you can see, the bisector is being drawn. Let's try the bisector from midpoint. It's the same procedure as the bisector, where you have to start the bisector line, choose the angle to bisect. But the difference is that the bisector has a pinned midpoint, and the length of this bisector is depending on this midpoint. This is the bisector from midpoint. Now let's try the angled line. The angled line is also the same procedure as the bisector line, where you have to start a baseline, but there is no midpoint for this angle. You should choose the angle. As you can see in the command prompt, it is asking you to state your angle. Let's say I want to create my line at 50 degrees from the baseline. So I write 50, enter, and as you can see, my line is inclined 50 degrees from the imaginary baseline. So basically the other commands are curve related and surface related. We will get back to them later. Now let's delete everything in the viewport and start with the curves. This button has everything related to lines and polylines, and this button has everything related to curves. The first command is the control point curve. It is used to construct a curved line by putting certain points. So the first thing to do is to choose the start of this curve, and then start by putting other points. They are called the control points, and they control the curvature of the curve. We keep on choosing points until we reach our desired form. And to exit this command, we press Enter, space, or the right click of the mouse. Now let's try the handle curve. The handle curve is the same as the control point curve. The control points are as anchor points, and anchor points help you control the direction of the curve. And as you can see, each point has an anchor point. Another button is the sketch button. This button helps you draw freely any shape, and it will be transformed into a curve. All you have to do is to keep on pressing on the left click of the mouse, and when you finish drawing the desired form, you release. And as you can see, the drawn line is transformed into a curve. Now let's clean up the viewport and start by exploring new commands. And since we have no polyline inside the viewport, let's draw a new polyline in order to understand this command. For example, this is our polyline. And this command is used in order to create a curve through this polyline. So Rhino is telling us to select the polyline that we want to work on and press Enter. As you can see, a curve is being created through this polyline. You can adjust the curvature of this curve by left-clicking on the degree and changing the degree number. For example, let's put the number 2 and press Enter. As you can see, the curvature of the curve has changed. You can also change the curve type of this curve by left-clicking this option, or by writing C. Let's choose the interpolated, or you can type I and enter. And as you can see, the curve now is intersecting the polyline from the outside. You can re-click on the curve type and choose control point, and it will become in its initial position as before. Now let's choose other commands, such as the parabolas. You have two types of parabolas: parabola from 3 points and parabola by focus. In order to create a parabola from 3 points, you should choose the starting point, the peak point, the end point, and finally you have to choose the direction of this parabola. Whereas the parabola by focus, you should start by the focal point or the peak point of the parabola. Then you choose the direction of the parabola. You could choose any direction you want. Let's say this direction. And as you can see, the parabola is controlled by this peak point or focal point. You can construct also a parabola by vertex. So you choose the vertex of this parabola, then you choose the focal point. As you can see, it's being constructed by the vertex. So this is everything related to parabolas. So another command is the conic command. And conic means constructing a curve between an imaginary angle. So we have to start the conic at a certain point, end it at another. Then we have to choose a vertex point for this angle. And as you can see, a curve is being constructed between this angle. And once we fix the direction of this curve, the angle will disappear. Another type of conic is tangent at start, where the starting point of the conic is a tangent point on another curve. So we have to select any curve, let's say this one. So as you can see, the starting point of the conic is a tangent point on this curve. You can choose any point. Let's say I want to choose this point. Then you have to choose an end for this conic, then the vertex. And as you can see, the starting point of the conic is tangent to this curve. Now let's try the helix command. The helix is a coil-shaped curve. You have to start by choosing the axis of this helix. And you can type down the radius that you want this helix to have, or you can do it manually. As you can see, a coil-shaped curve is being formed. A similar command is the spiral curve, where also you have to select an axis. But the difference is that each side you can have different radiuses. For example, the radius of the upper part, let's say it's this much. And you can make the other side smaller or bigger, depending on your style. So now, as you can see, we have a coned helix named a spiral curve, and we have this helix. So that's the difference between a spiral curve and a helix. Now let's try tween between two curves. And tween between two curves is when you have two curves fused together to form a new curve. And this new curve has the characteristics of both curves. For example, let's construct a polyline and a curve. Let's select both of them and click on the tween button. Then we press enter. As you can see, a new curve between the polyline and the curve is formed, and this curve has the characteristics of the polyline and the characteristics of the curve. Now there are few commands that are related to curves present under the polyline button. For example, let's try the perpendicular from curve button. The perpendicular from curve is when you draw a perpendicular line to a certain point on another curve. For example, I want a perpendicular line on this segment of this polyline. So I'll choose any point on this segment, let's say this point. And as you can see, a perpendicular line appears. You can choose this point or any other point on this polyline. For example, I want now my perpendicular line to be perpendicular on this segment. So all I would do is that I would elongate my perpendicular line as much as I want and left click the mouse. And as you can see, the perpendicular line is perpendicular to this line segment of the polyline because I chose it. Another command we have, for example, tangent to two curves. Rhino is telling you to choose the first curve and the second curve, and as you can see, a line which is tangent to both curves is being formed. Another command is the tangent from curve. The tangent from curves allows you to create a line or a polyline which is tangent to a certain point on any curve. As you can see, you can choose any curve you want. For example, I want this line. And as you can see, I created a line which is tangent to the point that I chose. Now, if you want to convert a curve to a polyline, all you have to do is to press this button. For example, I want to convert this curve to a polyline. All I have to do is to click on this curve and press enter. And as you can see, this curve is now divided into several polylines. And several polylines create a curve. So basically, that's everything related to curves. Now let me introduce you into a new section. And this section is the point section. And as you know, any curve, line, or any shape is made up of points linked together. So in order to construct one point, you left click on this button. And as you can see, one single point is drawn. Now, if you want to create multiple points, all you have to do is to right click on this button and you can choose as much as you want. As you can see, I created multiple points. Now, those two options are also present in the list of the buttons. The first button is the single point button and the second one is the multiple points. The third button is called the extract points. As you know, every curve has points in it. And if you want to select, for example, this polyline, as you can see, it's formed by 6 points, but you cannot select those points. You have to extract them at first. So in order to select the points inside this polyline, you should click on the extract button. You have to choose the object that you want to extract the point from. For example, let's say I want to choose this polyline. After you choose this polyline, you press enter. And as you can see now, the points that are forming this polyline are highlighted or selected. And as you can see now, you can choose each point separately. They are now extracted from this polyline. You can do the same thing to any shape you want. For example, let's say you want to do do we want to extract the point of this line? You press the extract button, you choose the object that you want, you press enter, and the points of this object are extracted. Let's try other commands under the point button. For example, let's start by trying the divide curve by length. It is telling us to select a curve to divide it. Let's select this line, for example, and after selection, we press the enter. The length of this curve is 202.22 and we are dividing by length. So I want this curve to be divided into segments, and each segment is, for example, 20 meters. So all I have to do is to click on the command prompt and write 20. Then I press enter. And as you can see, the 202 meter curve is now divided into equal parts, and each part is equal to 20 meters. Let's try the divide curve by the number of segments. They are also telling us to select a curve to divide it. Let's choose this one. After selection, I press the enter button. Now they are telling us to choose the number of segments in order to be divided. Let's say I want to divide this curve into 10 segments. All I have to do is write 10. And as you can see now, this line is divided into 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 segments. Now let's try the point cloud. A point cloud is a series of points joined together as a group. So they are telling us to choose the points. For example, I want to choose these points with this one. I press enter, and as you can see, the other points, I can select each point alone, while in the point cloud, it is acting as a group, so the whole points are selected together. This is called a point cloud. Now you can add points to this point cloud by pressing on this button. So let's say I want to add these to this point cloud. I choose the previous point cloud. And now, as you can see, these points are included in the previous point cloud. Now let's say I want to create a point grid. I press on this button and I have to create like a box, and inside this box there is the point grid. So I have to create the first corner of the base, the other corner of the base. I have to select the width of the base, and as you can see, a point grid is being created, and it also acts as a group, so you cannot select one point. If you select the point grid, all the points will be selected. So basically, this is what is related to points. Now let's talk about the construction of circles. Anything related to circles is present under this button. Now, in order to draw a circle, you should click on this button. It is telling me to choose a center for the circle. For example, I want this point to be the center of the circle. Now it's telling me to choose the radius. You can choose any point you want manually, or you can type the radius in the command prompt. For example, I want this circle to have a radius of 70 meters. I write 70 and I press enter. As you can see, a circle of radius 70 meters is drawn. Now let's see other options. For example, drawing a circle by diameter. Now it's telling me to start the diameter of this circle. For example, I want this diameter to start at this point. Now I could choose another point manually, or I can just type down the diameter that I want. For example, I want my circle to have a diameter of 100 meters. I tap 100. Then I want to left click the mouse in order to fix this circle in place. Now I have a circle of diameter 100 meters. Another option is to construct a circle from 3 points, where you choose the first point, second point, and the third point. Now I have 3 circles: circle created by radius, circle created by diameter, and circle created by 3 points. Now let's try the circle around a curve. They are telling me to select a curve. Let's say I want this curve. Now Rhino is asking me to choose a center for the circle on this curve, any point on this curve. So let me choose, for example, this point. Now I have to choose the radius of this circle. Let's say 50. I press enter. In the top view, you can see it, just a line. But if you go to the perspective view, you can see that there is a circle around this curve. And the center of this circle is a point on this curve. Another option is a circle with tangent. Now I have to select or choose the first tangent curve. Let me choose, for example, the tangent on this curve. Now I have to select a second tangent. So I choose any point on this curve to be the tangent point with this circle. Let's say I want my circle to be tangent at this point. And as you can see, my circle is tangent to this curve at this point. Now let's try the circle deformable. It's the same as the circle, but if we draw it, the circle is not perfect. It's not a perfect circle. It's like a sketchy circle. And you can use this option if you want to sketch something and you don't want a perfect circle to be made. Now let's try the final option inside the circle section, which is creating circles through fit points. I have to select some points inside the viewport. Let's say I want to select those points. Once I finish selecting, I press enter. And as you can see, a circle is being created through these points that I selected. So there are too many ways to create circles, and this is basically everything related to circles. Now let's move to a new section, which is the rectangle section. And everything related to rectangles is present under this button. Now, in order to create a rectangle, you should press on this button. It is telling me to choose the first corner of the rectangle. Let's say I want to choose this corner. I could choose another corner for this rectangle, or I could type the length of my rectangle. Let's try, for example, the length of 30 meters. Now, as you can see, the length of my rectangle is stable, which is 30 meters. I press enter. Now it's telling me to choose the width. Let's say I want to choose the width of 80. Now, as you can see, my rectangle is formed and having a length of 30 and width of 80. Now let's try to make this rectangle by putting the first corner and the other corner. So as you can see, I created a rectangle with random dimensions. Another option for the rectangle is creating a rectangle through the center, where I have to choose at first as a starting point for this rectangle, the center of the rectangle. Now, as you can see, everything is controlled by its center. I could choose a corner, or I could enter the length and the width of this rectangle. So let's the first option be by selecting a random corner. As you can see, I created a rectangle using the center as the starting point and having random dimensions. Now I would do the same procedure, but I will choose the length and the width of this rectangle. Let's have a length of 100 meters and the width of 50 meters. As you can see, I created this small rectangle with dimensions of 100 meters in length and 50 meters in width. Another option for creating a rectangle is through 3 points, where you start by selecting a point which is the edge point of this rectangle. You should also choose another edge for this rectangle, and I fix the rectangle anywhere I want. Now, as you can see, the edges or the angles of this rectangle are not perpendicular. It's like a sketchy rectangle. Now, the final option for the rectangle is the rounded rectangle, where I have to choose the first corner of the rectangle and the other corner. And the third click is how much I want the corner to be rounded. I could select the corner side to be rounded randomly, or I could choose or type the radius that I want. For example, I want a radius of 2 meters, or let's say 200. So as you can see, I have a rounded rectangle, I have a sketchy rectangle, and I have the two other forms, which is rectangle from the corner and rectangle from the center being created. So this is everything related to rectangles and how to form rectangles. Now let's try other sections, such as the arc section. Everything related to arcs is present under this button. Now, in order to draw an arc, we have to click on this button. We have to choose a center for this arc, a starting point, and an end point. Or we can type down the angle of this arc. For example, I want this arc to be at 40 degrees. So I type down 40. As you can see, the curve took this direction. But if I want my curve to take the other direction, all I have to do is to type -40 degrees. As you can see, the curve changed direction. Once I finish, I click enter and my arc is drawn. Another way to draw an arc is by having a start and point on arc, which means I have to start the arc at a certain point, end it at another point, and the third point is I have to choose the peak point of this arc. For example, I want this point to be the peak point of this arc, and the arc is formed. The third way to form an arc is by start, end, and direction at start, which means I have to start the arc at a certain point, end it at another point, and as you can see, there's an anchor point at the starting point of this arc, and this anchor determines the direction of the arc. Let's say I want to choose downward direction. So this is the third option for the arc. And the fourth option to create an arc is start, end, and radius, where you have to start the arc at a certain point, end it at another point, and you have to select or choose a radius for this arc. I will leave the chosen radius. So as you can see, I formed this fourth arc with a radius of 1685 meters. You can choose any radius you want. I just kept the one by default. So basically, this is everything about arcs. So the last category inside the line chapter is the polygon category. Everything related to polygons is available under this button. Now, in order to construct a polyline, you should click on this button. You should choose the center of the polygon and its corner. But before you choose the corner, you have to choose the number of sides of this polygon. For example, at this moment, this polygon has 5 sides. I want to change the number to 7. So I click on this tab and change the number to 7 and press enter. Now my polygon has 7 sides. Another way to construct a polygon is circumscribed polygon, which means I have to choose the center of the polygon and then type down the radius of this polygon. I could choose also different number of sides. Let's keep it on 7. Let's draw a radius of 500 meters. Now I constructed a polygon of 7 sides and radius 500 meters. A third way is polygon by edge, where I have to choose at first the edge as a starting point for this polygon, and I have to choose the end edge of this polygon. As you can see, I constructed a polygon by choosing the starting point and the end point. And those points are the edges of this polygon. Now, if I want to create a square, all I have to do is to choose the center. And as you can see, the square is being formed. Another option is the circumscribed square, where I have to choose the center of the square and I have to determine the distance between the midpoint of the square and side. Or in other words, I have to choose the radius of the square. Let's say I want the square to have a distance of 1000 meters. So This is a square with radius 1000 meters. Another option is to create a square by the edge, where I choose the edges of this square, the starting edge and the end edge. I can choose any point I want. So this is another way to construct a square. And the final shape is the star, where I have to choose the center of the star, the corner of the star. Before I choose the corner of the star, I have to choose the number of the peak points of the star. For example, I want the star to have 6 sides. So now I choose the corner of the star. And then I choose the radius of the star. So this is everything inside the polygon category. And thank you so much for watching, and see you in the next video, the exercises video. In this video, you will start practicing the chapter of lines. So let's start with exercise 1. This beautiful lady wants to recreate herself in Rhino. She is demanding certain conditions. The first condition is that her face should start at 0.00 reference and with radius 20 centimeters. From this sentence, you'll understand that the unit needed inside this exercise is centimeters. So let's start the application of Rhino. Choose a new file and we have to choose the unit to be centimeters. There are 2 options for centimeters: large objects centimeters and small objects centimeters. And since our object is smaller than a truck dimension, you should select the small objects centimeters. Now, before starting anything inside the viewports, you should rename the file. So you click on File, Save As, choose a name for this file. Let's say I want to call it Exercise 01, and you save. As you can see in the window title, the title of this file changed into Exercise 01. Now, there are so many ways to recreate an object inside Rhino, but you have to choose the most efficient command to do the job. So as you can see in the given, the face of this beautiful lady, let's call her Jacky, is a circular shape. And she is telling us to recreate her face using radius. So we have to find a command that has a radius option. We go to Rhino. We open the list of the circle commands and we start looking for options. So the first option is to draw a circle with center and radius. We have another option with diameter, 3 points, circle around curve, circle, tangent, tangent, radius, tangent to 3 curves, fit points. So we have 2 options, either center radius or tangent, tangent, radius. But since we don't have anything tangent, you should choose the first option, center radius. Now, this lady wants her face to start at 0 point reference. So the center of the circle should be at 0 point. So we type in the command prompt 0 and we press enter. Now, as you can see, the center of this circle is at 0.00. The second step is to choose the radius of her face. By default, it's 20 centimeters, but if it is another number, you should type 20 and press enter. Now the face of Jacky is constructed. Now, after we constructed Jacky's face, let's see what's next. The second condition is that her eyes are 10 centimeters wide and away from her face by 5 centimeters. Let's start at first by doing the second part of the condition. You need a reference point in order to construct the eyes away from the face by 5 centimeters. So what I would do is that I would click on the single point and place a point as a reference point on the circle. Let's say I want the eyes to be at this position. So now I have a reference point. Then this reference point, I would move it 5 centimeters. So I would type inside the command prompt 5. Now, as you can see, this point is moving 5 centimeters away from its position. Now, in order to have like a straight direction, I keep on pressing shift and I release the left click of the mouse. Now, as you can see, this point is moved by 5 centimeters. Now, this is for this eye. In order to do the other eye, all I would do is that I would select this point, type copy inside the command prompt, and press shift in order to have a straight direction, and put the copy of this point at the circle. Now I press enter. As you can see, I have a copy of this point at the intersection of the circle or on this circle. Now I do the same procedure that I did on this eye here. So I would select the point, I would drag it, I would type at the command prompt 5, I press enter, then I keep on pressing shift, and I release the left click of the mouse and the shift. Now I have the corner of the eyes, the outer corner of the eyes, away from the face of Jacky by 5 centimeters. Another hint that Jacky gave us is that her eyes are 10 centimeters wide, and in another graph, she told us that her eye's diameter is 4 centimeters. So the horizontal diameter of her eye is 10 centimeters and the vertical diameter of her eye is 4 centimeters. And as we check the shape of Jacky's eyes, we can say that there are ellipses. So we have to check the ellipse section in order to find the most suitable option for Jacky's eyes. So let's try, for example, the deformable option. So as we know, Jacky's eyes are not deformable, so this option cannot be chosen. Another one is ellipse by corner. So we have the first corner of the eye, and we know the second corner is 10 centimeters away from the first one. So let's select the first corner and type 10. Then we press enter. The opposite corner, let's say it's 4. Let's redo this option again. Say it's at 10, we press enter. Then the other diameter is 4. So as you can see, the size of the eye has decreased. So this is not a suitable option for Jacky's eyes. Another option is around a curve, but we don't have any curve from Jacky's eyes. So this is not a good option. The fourth one is from foci. So we have the first focal point, which is the corner of the eye, and the second one is 10 centimeters away. Let's see if this will work. So let's try the vertical diameter, which is 4. As you can see, nothing happened because you can control only the horizontal axis. So this option won't work. Let's try a different one. Let's try, for example, this one, ellipse from center. We don't have the center of the ellipse, and it's so hard to determine where is the center. So this option won't work. So the final option is the ellipse by diameter. So we have the first axis, which is the horizontal axis, and it's 10 centimeters. And we have the vertical axis, which is 4 centimeters. But this axis is measured by radius. So if we want a diameter of 4, we have to type 2 centimeters. So now, as you can see, the first eye of Jacky is constructed with dimensions 10 centimeters by 4 centimeters. Now we could do the same thing for the other eye, or we can just type copy, choose the point of copying. For example, I want to choose this corner and move it to the other corner, to the point of reference. Then press enter. Now, as you can see, both of Jacky's eyes are constructed. Let's try the option without copying. So we do the same thing as we did for the first eye. We choose the diameter option. This is the first axis, type 10. Then we type 2. And as you can see, this is the second type of constructing Jacky's eyes. Now let's try to construct the inner side of the eye. It has a circular shape and a diameter of 4 centimeters because it's tangent to the ellipse part of the eye. So we have to find options such as diameters, radiuses, or tangent in order to create this circular part. So we go to the circle list and find the most suitable option. This first button is center and radius. We know everything about the radius, but we know nothing about the center of the eye. So this option will not work. The second option is the diameter. And we know in the given that the diameter is 4 centimeters. So this might work. They are telling us to choose the starting point of the diameter. Let's say the upper part of the eye. And the end of the diameter is the bottom part. So as you can see, the inner part of the eye is constructed. We can do copy from this eye to the other eye and everything will be done. But let's try other options. So let's enter the menu again and find other options. Circle tangent to 3 curves. So this is basically one curve to curve. There is no third curve. So this won't work. So we have tangent, tangent, radius. We have the first tangent, we have the second tangent, and we know the radius of the circle. So this might work too. This is the first point, and this is the second point. We choose the radius to be 2. And as you can see, the inner side is created. So this is 2 ways in order to create the inner side of Jacky's eyes. Now, if we see in the given, Jacky's pupils are not identical, so they are deformable, a kind of deformable. So what we will do is that we will choose the deformable option, choose a center. We assume, for example, the center of the pupil is here. And we create the pupil. So now we have Jacky's face and her eyes. One of the most important things in Jacky is her hair. Now, in order to create the first curly hair of Jacky, we should draw a tangent line to her face. Now, in order to create a tangent line, we should go to the line section and see the suitable command for drawing a tangent. So in this row, there is no tangent lines. In the other one, there is one possibility, which is tangent, perpendicular, and tangent from curve, and tangent from 2 curves. Those are the tangent options. So this one, tangent to 2 curves, there is only one curve. So this option is not possible. So let's try the tangent from curve. So we choose a point on this circle to be tangent to it. And we draw our line. So this option works. Let's delete and try the other option, which is tangent perpendicular. We start the line at a certain point, which is the tangent point on the circle, and we create our line. And this is possible too. So there are two options, valid options to draw a tangent to Jacky's face. There are tangent from curve or tangent perpendicular. Now, we have the curly hair. In order to create a curly hair, we should use the helix command. And the helix command is present under the curve button. Now I want to transform this straight hair into a curly one. So what I have to do is that I want to do this helix around this curve. So in the options, there is something called around curve. I click on it and I select the curve that I want it to be a helix. And in the given, it is telling me that this helix has a 2 centimeters radius. So I type 2, press enter. And as you can see, a helix is formed around this straight line. Now, if I don't want this straight line, I just can delete it, leaving the curly hair. Or there's another option where I can draw above this straight line. So let's go to the helix part and we start the axis at a certain point, let's say at the beginning of the tangent line, and the end of axis at the end. And I type the radius that I want, which is 2, and the helix is created. So I can redraw above the straight line, or I can construct a helix around this curve. Now let's construct Jacky's hair. The second hair is 40 degrees from the first and has a radius of 2 centimeters. And the third hair is 40 degrees from the second, also with a radius of 2 centimeters. So the overall angle of Jacky's hair is 80 degrees in order to construct the third hair. So let's start with the third one. So we have to find under the line section something related to angles. And the two sections or the two commands that are related to angles are the bisector and the angle. And I think the most logical one to use is the angled command. So we choose a baseline, which is tangent line. Then we choose the angle, which is 80 degrees. Then you choose the length of the hair. You can choose any length you want because it's not specified. And the third hair is constructed. Now, in order to transform it into a curly hair, the same procedure that happened here will happen again. So I will choose the helix command, click on around curve, select this curve, type 2 for the radius of the helix, and this is the third hair. Now, in order to construct the second hair, which is 40 degrees from the first one and 40 degrees from the second, this means that the second hair is the bisector of this angle. So the most logical command to use is the bisector angle. So we choose the start of angle, end of angle, and we choose the length of the hair. Now let's construct the curly hair. We choose the helix. We start the axis. We end it at the end point. And we type 2 for the radius. And it's constructed. Now all we have to do is to delete the straight curves. And this is the curly part of Jacky. Now let's create the other part of Jacky's hair, which is made up of straight hair tangent to face and a curved hair 60 degrees. Let's start with the straight hair. We did this before, so I will be repeating the steps. So I go to the line section and I choose either tangent from curve or tangent perpendicular. So let me choose tangent from curve. I choose a point on this circle, say 1, and I choose the length of my line. Say this is it. And this is how the straight hair is done. Now, we have to find a certain curve that has something related to degrees. And the only curve that has something like this is the conic. There are two types of conic and conic tangent at start. And since the curve is intersecting the circle and the straight line, so I think the best option to choose is the conic tangent at start. So we have to select the starting curve, which is face of Jacky. Then I have to select the first point of tangency and the end of the conic. Let's say the point intersecting the straight hair. And then I have to type 60 in order to create this angle. And now this is how the curved hair at 60 degrees is made. Now let's create the nose of Jacky. In the given, the nose is 5 by 10 centimeters and the nose is away from the left eye by 2 centimeters. So basically this is the nose, 5 by 10, and it's away from this corner by 2 centimeters. So the first step to do is to create a reference point. So we click on single point and we put a point on the other corner of the left eye. Then we move this point by 2 centimeters. Keep on pressing shift in order to have a straight direction. And we release the left click of the mouse. So now we have the reference of the nose. Now we go to the rectangle section and we choose the most suitable command in order to create the nose. Let's start by corner to corner. So we have to choose the first corner of the rectangle. The first corner is the reference point that we made before, is this one. Then you type down the length, which is 5 centimeters. Press enter. And then you enter the width, it's 10. So sometimes the nose is flipped. All you have to do is to type down minus 10, minus the value you want to put. And as you can see, the direction of the nose works. Let's try other options. Let's try, for example, the rectangle center corner. The first thing that they are telling us to do is to choose the center of the rectangle. But since we don't have a reference point as a center, we cannot use this command. Other command is 3 points. We have to choose the first edge, which is the reference point, and the end of this edge is 5 centimeters. Then we have to type the width. Let's try 10 centimeters, not minus 10. And as you can see, the direction is correct. So this is another way to draw the nose of Jacky. And Jacky don't have a rounded rectangle nose. So basically, those are the two possible ways in order to draw the nose. Now let's construct the mouth. The only information that we have about the mouth is that it's away from the nose by 5 centimeters. And this point of the mouth is the same as the midpoint of the nose. So what we have to do is that we have to create a reference point at the midpoint of the nose and move it 5 centimeters downwards. Then we have to create the straight line that separates the upper lip from the lower lip. So we click on the line section and we create a single line. Choose random starting point and random end point. Now it's time to create the curves of the upper lip. As we can see that there is a starting point, a peak point, and an end point. So I think the most suitable command is the parabola from 3 points, because it has starting point, peak point, and an end point. So the starting point is this point. Then you can choose any peak you want. Say I want to use this one. And the end point is at our reference point. We press enter. This is the first side of the upper lip. Then we do the same procedure for the other side. Peak and the end point. Press enter. And this is how you create the upper lip. Now the bottom lip is shaped as a curve. It could be a parabola too. So we can do the same method as the upper lip, which was the starting point, peak point, and the bottom point. So let's try it. The starting point. This is the end point. So as you can see, the lips of Jacky are constructed. Now we can try other options for the bottom lip. For example, we can try the arc section. You can choose the start, end, and the radius. We choose a starting point for the arc, an end point for the arc, and we type down the radius or we set it manually. So this is another way to create the bottom lip. Let's try other options. Let's try, for example, start and point on arc. So we start the arc at a certain point, we end it at another, and we choose a different peak. This is the old arc, and this is the new one. So this is another way to draw the bottom lip with arcs. You can choose also this one, start and direction at start. Let us first delete this one and try to do this option. They are telling us to start the arc at a certain point, end it at another, and we have this anchor at the start, which help us control the bottom lip. We choose any point. So as you can see, this is another way to construct the bottom lip. So there are so many ways, 3 ways in arcs and the parabola and the curve. So basically this is all about the lips. Now we should draw the shoulders of Jacky, and the shoulders are made up of 2 arcs. Each arc is 45 degrees. So we have to search inside the arc commands for an angle option. So the first button has center, start, and angle, and the other options don't have the angle option. So this is the only choice that we have. Now they are telling us to choose a center for this arc, but we don't have a reference point for this arc. So we have to create one. We press on the point and we choose any point in the viewport as a reference point for center of the arc. Let's say this point. Now we re-enter the arc section and we choose this option. Now we have to choose the center of the arc, which is our reference point, and then we have to start to choose the starting point of the arc. At this moment, we have to draw the shoulders of Jacky. Her shoulders are made up of 2 arcs. Each arc is 45 degrees. So we have to find an option inside the arc commands that has angles. The first button is center, start, and angle. And the other options don't have the angle option. So the best button is this one. Now it's demanding me to choose a center for this arc, but I don't know where is the center of this arc, so I have to create one. So I select a single point and place it anywhere in the viewport for reference. So I want to place it right here. So this reference point will act as the center of my arc. Then I re-choose this option, choose the center of the arc, which is my reference point. Then I have to choose the starting point of the arc. And the starting point is the face of Jacky. Then I have to go 45 degrees in order to construct the first shoulder. So I type 45, press enter, and this is my shoulder. I do the same thing for the other shoulder. So I press this button, choose my center. I choose my starting point of the arc and I type 45 degrees. As you can see, it's giving me the same angle. So I have to retype minus 45 degrees in order to get opposite direction. This beautiful lady follows the fashion, so she has hair bangs. There are so many ways to create them, and they are basically made up of curves. So let's try some options inside the curve button. Let's start by the control point curve. So we have to choose a starting point, then we choose another point and an end point. So this is the first bang. And we do the same thing for the other side. This is the first option. The second option is the handle curve, which is setting up some anchors. So I want to choose this point as the first anchor. This is the second, and the third is on the eye. But I don't want to change the direction of the bang, so I just press enter. And I do the same thing. I place some anchors for the other side. And I press enter. So this is option 2 to create Jacky's bangs. Let's try other commands, such as the sketch. You can create bangs, but it's somehow inaccurate. So I prefer not to use it at this moment. You can use it if you want to sketch something, or you have something that is not accurate on purpose. So you can use this command as a sketch. This command cannot be used because we don't have a polyline, and this one too because we don't have an angle. So the other option that is possible is the parabola, and it's similar to the one that we used for the upper lip construction. So we choose a starting point, we choose a peak point, and an end point. Then we press end. So those are the 3 possibilities to construct the hair bangs of Jacky. So this lady loves to add some accessories to her looks. So she's wearing a squarish hat with polygons in it, and each side of this hat is 15.32. Now, in order to construct a square inside Rhino, you should go under the polygon section. And there are 3 types of squares. The first one is center corner, but we don't know the center of the square, so this option is eliminated. The other option is center radius. We don't know the center and we don't know the radius, so this is not possible too. The third option is the edge, and we know that the edge is 15.32, or another way to know the edge is that the hat is intersecting the face at this point and at the intersection point of the curly hair. So let's start by choosing this option. The first edge is at the intersection point of the curly hair, and the second edge is at the intersection of the bangs. So this is how we create the hat. Now the polygons inside the hat has 1, 2, 3, 4, 5, 6, 6 sides. So we choose this polygon and we change the number of sides to 6. And we put random shapes in order to decorate this hat, different radiuses. So this is all about the hat. Now this recreation period happened at night and stars were present in the sky. In order to reconstruct the stars, we should go to the polygon section and choose the polygon of star. The first star has 1, 2, 3, 4, 5, 6 sides. So the number of sides is correct. Now we have to choose a center for the star. You can choose any point as a center. Let's say, for example, I want this point to be the center of the star. Then we choose the first radius, which is 10 centimeters. And then we choose the second radius, which is 2 centimeters. Let's try the command again. So this is the first star. Let's try the other star, which has the radius 1 of 5 centimeters and radius 2 of 2 centimeters. So we go back, the star polygon, we choose center for the star. The first radius is 5 and the second radius is 2. And the third star has the radius of 7 centimeters as the first radius and the second radius as 1 centimeter. So we right click the mouse in order to restart this command. We choose center for the star. So we created the 3 stars that were present in the sky. Now, in order to clean up everything, we delete all the reference points. So this is basically Jacky. Now, if you close up to Jacky's face, you can see that there are some freckles. So in order to create those freckles, we have to put some random points on Jacky's cheeks, and then we have to transform these points into cloud points. Select all the points. Now we can say that Jacky is complete. So this is the end of exercise 1. Thank you so much for watching, and please keep on watching more videos in order to become experts in Rhino. In this video, I will be introducing surfaces. What are surfaces? Surfaces are faces that make up any object, and every set of curves joined together in order to form a closed loop form an imaginary surface. So in other words, surfaces are made up of lines joined together in a loop. Now let's take an example, the cube. This cube is made up of 6 faces, so we can say that it is made up of 6 surfaces. And the surfaces are not limited to the rectangular shape, so you can have this cylinder, for example, and this cylinder is made up of 4 surfaces, and each surface can be filled or hollow. So this is basically what is a surface. Now, if you open the Rhino application, you would see this grid in every viewport. And this grid has a certain direction, which is horizontal. It's not vertical, it's horizontal. And this grid, if you try to select it, it won't be selected. This is because this grid is called a plane. And a plane is an imaginary reference surface. So this is a surface which is imaginary, it's a reference, and you can change the direction of this plane. So you can change the reference of this plane. Now let's start with creating surfaces. So everything related to surfaces is under this button. Now, if you open Rhino, you can see that there's a grid inside every viewport. This grid can be placed horizontally, vertically, or diagonally, or in any direction, and it is called a plane. A plane is an imaginary reference surface. So the first surface that you will encounter in Rhino is this grid. Now let's construct surfaces inside the viewport. And the button that is responsible for creating surfaces is this button. Now let's open the list of the surfaces and try some options to create the surfaces. The first option is the surface from 3 or 4 corner points. So the first thing to do is to choose the first corner for the surface, second corner, the third corner, and the fourth corner. As you can see, the surface is made up of certain lines joined together by points in a closed loop. So let's say our fourth point is here. The first surface is created by 4 points. The different thing is that I'm working in the perspective viewport because I think it's easier for me to work in a 3D context. And in order not to be distracted by the other viewports, I double click on the title of the viewport and I enlarge the desired viewport. So I'm working in the perspective viewport. Now, if I want to create a surface with 3 points, I go to the same button and I choose only 3 points. I don't choose the fourth point. All I have to do is to press the enter and the surface is created by 3 points. This is how the viewport is seen in a wireframe view, but in a shaded view, you can see that the surface has some shading because it's a face, it's not lines. Now let's try other options under the surface list. So let's try the surface from planar curves, which means transforming curves that are joined together in a certain loop, or in other words, the imaginary surfaces into actual surfaces. So let's construct a closed polyline. So you can see a bunch of lines joined together, but you cannot see a surface. So in order to transform this one to this one, you have to click on this button, select the curves that you want to transform, and then press enter when done. Now you can see the surface that we created, and it takes the same form and shape of the lines that we drew. This is because the surface overlaps the line. So if we move the surface, we can still see the lines. Now, another option is creating surface from 2, 3, 4 edge curves, which means if you want to create a surface but you don't want the lines to be joined together, you can choose this option. Let's draw a single line and another one. And I want to create like a surface of these 2 lines. I could select the lines that I want and choose this option. And now you can see that I created a surface from only 2 lines. You can do this option with 3 lines or 4 lines. Let's try, for example, 3 lines. They are telling me to select 2, 3, or 4 open curves. Then I press enter when done. And this is the surface created by our 3 lines. So let's try other options under the surface button. Let's try the surface from network of curves. And it is when you create a surface from open curves, but they are related or connected to each other. And this command doesn't work unless you have 3 or more curves. So let's start by creating some curves. There's curve number 1, 2, 3. Now, as you can see, those curves are open curves. They are not closed, but they are connected in a certain way because they are intersecting each other at a certain point. So as you can see, curve 1 is intersecting curve 2 here, curve 2 intersecting curve 3 at this point, and curve 3 is intersecting curve 4 at this point. Now, in order to transform those curves into a surface, you should select all the network and click on this button. Now you can see that a certain surface is being created from these points or from these curves. And as we said before, that a surface by definition is a set of lines forming the surface. So as you can see that certain lines are forming this surface. You can decrease the number of lines or you can increase the number of lines as much as you want. So you can play with these numbers. For example, I will change the 0.001 into 0.05. And now as you can see, the lines that are creating this surface decreased in number. Let's try other commands under the corner-to-corner option. So we've tried the 3-point, the vertical. Let's try the center. So it's telling me to choose the center of the plane. So let's choose a point. Now, as you can see, the center of this plane is the reference point to construct a surface. You can choose any point in the viewport to continue drawing or constructing the surface, or you can enter the length and the width that you want the surface to have. Let's say I want my surface to have a length of 20 and a width of 10. Now my surface is constructed having dimensions of 20 meters by 10 meters. And the reference point for constructing this surface is center. Another option is a round curve, where you have to select a curve. Let's say I want to select this curve. Then you have to choose a point on this curve. Say I want this point. Now a surface is being constructed around this point, where this point is the center of my surface. You can choose a random point, or you can enter the length and width of the surface. Let's say I want to choose a random point. And now my surface is constructed around this curve, and having the point that I chose on this curve the center point of my surface. Now the final option inside this command is the deformable, where you can create a surface that is not 100% straight, or it doesn't have a 90 degrees angle. So for example, let's try it. Let's try to construct a deformable one above a normal one. See the difference? You zoom in, you can see that the deformable one is not overlapping the right one because it doesn't have the right angles. It's kind of deformable. So this is why it's called deformable. So this is several ways to create a surface. Now there is another command, which is rectangular plane 3 points. You can choose this command from here, or you can go to the corner to corner and choose this option from the command prompt. It's the same option. Let's try it from this one. So it's telling me to choose a starting point for my edge and an end point. And also it's telling me to choose a third point. So this is another option or another way to create a 3-point surface. If you want to create a vertical plane like we did for this box, but you don't want to go to a rectangular plane corner to corner, then choose vertical every time you want to create a vertical plane, there's a simpler way. All you have to do is to go to the list of surfaces and choose this button. It's called vertical plane. It's the same procedure. You have to choose a start point for the edge and an end point. And then you choose the height of your surface. Let's say you want your surface to have a height of 30. You press enter. Then you choose the direction of the surface, upwards or downwards. And when you choose your option, you left click on the mouse. and the surface is created. You can also construct surfaces from points or through points. So you have to click this one, fit plane through points, but we don't have any points in the viewport, so let's construct some points. Let's say I have these points. I choose this command, then I have to select my points that I want my surface to be through them. Let's say I chose those. Then I press enter when I finish. And I created a surface to the points that I chose. There are so many options, but I'll save them for later. But there is one that I like a lot, which is add a picture plane. So you can add any picture you want, JPEG from the internet, to the viewport. So it's telling me to choose any picture I want inside my computer. Let's say I want this one. I press open. I choose the first corner of my picture. Then I choose the second point, or I can just type down length and width for my picture. And I've inserted a picture plane or a surface that has a picture into my viewport. Let's try surface from point grid. So let's create a point grid at first. Let's say I have this point grid. Now it's telling me to choose the number of points and the U direction. Let's say I want to choose 2 points. So it's telling me in the command menu that I have to choose at least 3 points. So I cannot choose 2. Now I go to the point grid and choose the points. So it's telling me to choose 1 out of 3. So let me choose this one. 2 out of 3, 3 out of 3. Then I have to go to the other set, choose 3 other points. And I created a surface through point grids. So it's just like linking the points that I chose inside the point grid in order to form a certain surface. Since I introduced what is a surface and what is a plane, now I have to tell you about some commands that are inside the line and curve sections that are related to surfaces and planes. Let's start with the line section. For example, we have this command, which is called normal to surface. Normal means perpendicular, so we will create a line which is perpendicular to the surface. The first step is to choose the surface for the normal line. Then we have to choose a point on the surface. For example, I want to choose this point as a starting point for my line. Then I have to choose an end point for my line. Let's say I want my line to end at this point. As you can see, I created a line which is perpendicular to this surface. In the same command, you can choose the starting point to be the midpoint of this line. So all you have to do is to right click on this command, select the surface, choose a corner, and now as you can see, my starting point is the midpoint of this line. So the intersection point between the line and the surface is the midpoint of the line. Another command is vertical to C-plane. So the C-plane in this viewport is the grid. And the grid is placed horizontally, as you can see. So I will be creating a line which is perpendicular to this grid. So I have to click the starting point and the end point. Now you can see that I created a line which is perpendicular to my C-plane. You can also do the same thing by having the starting point as the midpoint of the line. Another command is creating a circle vertical to the C-plane. Now you have to start by choosing the center of the circle and the radius of the circle. I will choose the radius to be randomly chosen. I will choose a normal radius. And now, as you can see, the circle is the other direction of the grid. So it's like perpendicular to my grid or to the C-plane. It's not horizontally, it's placed vertically. The same goes for the rectangle. So it's telling me to start the edge of the rectangle. And I created a rectangle which is also perpendicular to my C-plane. So you can say that this is a rectangle on the C-plane having the same direction as the C-plane, which is horizontally. And this is a rectangle having a perpendicular direction to the C-plane. So basically, those are the other commands related to surfaces. Thank you so much for watching, and don't forget to watch other videos in order to become experts in Rhino. In the previous video, I talked about surfaces. Now in this video, I will be talking about meshes. But what is a mesh? A mesh is a kind of surface which is made up of triangulations and polygons, whereas a surface is made up of lines and curves. This is a picture of a surface, and it is made up of 1, 2, 3 lines and a curve in the middle, while the mesh is made up of a series of rectangles. It could be a series of rectangles, triangles, polygons, or any geometrical shape. Now, if we go to Rhino and we want to draw a mesh, you cannot draw a mesh by itself. The first thing to do is to draw a surface and transform this surface into a mesh. And to do so, there's a button for the meshes, which is this one. And this is the list related to the mesh. Now, the first button in this list is Mesh from Surface or Polysurface. The first step is to select the surface, then press Enter. The second step is to choose how much polygons I want this mesh to have. I want fewer polygons or I want more polygons. Let's start by having like one with more polygons. Then I press OK. And my mesh is created above my surface. So all I have to do is move one of them. They have the same shape, but you can differentiate between them. This is a surface and this is a mesh. And if you select any one of them, you could go to the command list and see what you selected. So here they are telling me that I selected one surface. If I select a mesh, it will tell me that I selected a mesh. Now let's try to construct another mesh but with fewer polygons. Now, as you can see, the number of rectangles creating this object has decreased because I chose less polygons. Now let's move the meshes next to each other. Now, as you can see, this mesh is made up of polygons, and each polygon in this mesh acts as a small independent surface. But those surfaces are connected and joined together in order to form one identity or object, which is the mesh. Let's try some options for this mesh. Everything related to mesh is, as I said, inside this list. Let's choose, for example, delete mesh faces. Every independent surface in this mesh is called a mesh face. So it's telling me to choose the mesh faces that I want to delete. Everything that is in yellow means that it is selected. So I'm selecting a bunch of mesh faces. Let's say I want to delete these mesh faces. I press enter, and as you can see, a hole will be created inside my mesh. Now, if I want to fix this hole, there is a command called fill mesh hole, and by its name we can tell that it fills the holes inside the mesh. So now you have to choose the mesh edge on the hole boundary. And as you can see, this hole is filled. But it is not filled like before. It's not in a rectangular shape, it's in a triangular shape. Let's move the meshes next to each other. Now, as you zoom to this mesh, you can see that it's made up of polygons. And every polygon in this mesh acts as a small independent surface. But those surfaces are connected and joined together in order to form one identity or object, which is the mesh. Now let's try some options related to this mesh. One option is delete mesh faces. Every surface inside this mesh is called a mesh face. So it's telling me to select some mesh faces to delete them. So you select a bunch of mesh faces. You can choose any mesh face that you want. Let's say I want to select these mesh faces. Then I press enter. And the result is a hole inside my mesh. Now there is a way to fix this hole inside this mesh by a command called fill mesh hole. As its name says, it fills the holes inside the mesh. Now I have to select any edge of my hole. Let's say I want to select this edge, and my hole will be filled. Now the filling is not the same as the other mesh or the other part of the mesh. It is triangular and you cannot fix anything about it. Always the filling will be in a triangular shape. Now, if you want to convert this mesh into triangles, there's a command called triangulate mesh. You click on this button, you select the mesh, and the mesh will be triangulated. And as you can see, the filled part is not changed. It's stable. And everything around the hole will be triangulated. Now let's try other options under this list. Let's try the mesh from points. It's telling me to select the points, but I don't have any points in the viewport. So let's create some points. Let's say these are my points. Then I have to select them. I press enter twice. And my mesh is created. Now, if you notice that my mesh is triangulated, it's not rectangular or squarish or any other shape, but I want to transform it into squares. There's a command similar to the one that I used here to triangulate my mesh. It is called quadrangulate mesh. So I select it, then I select the mesh that I want to transform, then I press enter. I enter some values. Mine is 11 by 20 by 1 in order to transform from triangles into squares. So you can put any number you want and press OK. Now you can see that the triangles are transformed into squares. And if you want to go back to the triangles, you just click on the other option, which is triangulate mesh. Select the mesh that you want to triangulate and press enter. It will go back to the triangular shape. Another way to create a mesh is by creating a mesh by lines. So you have to draw some lines, and these lines should be close together or creating a polyline. Now you go to the mesh list and choose this option, which is creating mesh from 3 or more lines. Then you have to select your lines, then press enter, and a mesh is created by 4 lines or a polygon. Now if you select this one, you can see that in the command window it's saying that you selected one mesh and not one surface. That's another way. Now if you want to know how many polygons you have inside this mesh or this mesh, you select the mesh that you want and you go to this command, which is called polygon count. Now you go and read inside the command window. It's saying that there are no quadrilateral polygons and there is 72 triangular polygons. Let's try the other one. There are 0 quadrilateral polygons and 910 triangular polygons. Now if we transform this one into squares and retyped this command, you will see that the 0 has changed into 36 quadrilateral polygons and 0 triangular polygons. So this is an easier way to count the polygons inside the mesh. Now let's explore other commands, such as add a mesh face. This command is used in order to join two meshes together by mesh faces. So the first thing to do is to go to one mesh and select either a mesh vertex or a mesh edge. Let's choose, for example, a mesh vertex at first, and then you go to the other mesh and choose an edge. Now you can see that this mesh is linked to this mesh by this mesh face, and if you select this mesh, both of them will be selected because they are joined together by this mesh face. Let's try the same command, but this time I want to choose a mesh edge. Now you can see the difference between a mesh vertex and a mesh edge. Here it is connected by the vertex of this mesh, while this mesh face is connected by the other one by the edge. Both meshes are now connected to each other, and even if you delete this connection of the mesh faces, the meshes are still connected and selected together. Now in order to split them, there is a command called split disjoint mesh, where you select the meshes that you want to split and press enter. Now in the command window, they are telling us that one mesh has split into two meshes. So they are back to the initial state. Now let's delete some of the connections here. Now if I select this mesh, there is no curve appearing in the hole. If you want a curve to be around this hole, there is a command called duplicate mesh hole boundary, where you select the mesh edge on the whole boundary, and a curve around this hole will appear. Inside the mesh list, there's a command called collapse mesh toolbar, and this button has another list in it. And this list has everything related to collapsing a mesh. Let's say I want to choose this button. It says collapse mesh faces by aspect ratio. I have to select a mesh. Then a window of aspect ratio will appear. I have to type down the aspect ratio, and as we increase the aspect ratio, the level of selected mesh faces will decrease. So now the aspect ratio is 4. The number of mesh faces is a lot. Well, if we select like an aspect ratio of 7, as you can see, the selected mesh faces decreased. Now if I press collapse, you can see that my mesh collapsed where I selected the mesh faces. Now let's try other options. Let's try collapse mesh faces by edge length. I have to select the mesh tool. Now it's selecting the edges inside this mesh. So it's the same thing. You can put any value you want. Let's say I want the value of 8. Now you can see that my mesh has collapsed by the length of the curves inside the mesh. There are other ways to collapse a mesh, such as collapsing mesh edge. We have to select the mesh edge to collapse. So as you can see, I'm clicking on the lines of the mesh faces, and it's collapsing by edge. You can choose any edge you want and any mesh face. Another option is collapsing by mesh vertex. Collapsing by mesh vertex is not collapsing by the line or the borders of the mesh face. It's collapsing by the points linking the mesh faces. So if you press on the edge, it won't collapse, but you have to press on the vertexes. So these are the ways to collapse a mesh inside the viewport. Moving forward, there's a command that merges the characteristics of meshes and surfaces together. So we have this mesh, for example, and we have this surface. This command is called apply mesh UVN. It tells me to select the mesh. Then it tells me to apply this mesh on any surface. So I have to select the surface that I want this mesh to be applied on. Now you can see that my mesh is being reconstructed on the surface, having the direction of this surface and the location of this surface too. Before I forget, there are other options under the mesh list. For example, there is a swap mesh edge command where you have to select or choose the edges of the mesh face. And as you can see, it changes direction. It's another form of collapsing a mesh, and this can be done on any face mesh you want. Now, there are certain commands related to meshes present under the polyline or the line section and the curve section. And this command is creating a polyline on mesh. So I have to select the mesh, and this helps me create a polyline on the mesh. And I cannot draw this polyline outside or in the viewport. It's just limited inside the mesh. I'm trying to go outside this mesh and I can't. So this is a polyline constructed on the mesh. A similar command is present under the curve section, which is sketch on polygon mesh. Gives you the opportunity to draw on the mesh or to sketch on the mesh, and it's limited on the mesh only. So as you can see, this part where I draw or sketch in the viewport just disappears. So basically this is everything related to meshes. Thank you so much for watching this video, and in the next video I will be targeting exercises related to surfaces, lines, and meshes. In this video, you will be practicing surfaces, meshes, and some lines. So this exercise is about an artist who participated in an art gallery show. His masterpiece is made up of a dining table with 2 3D printed chairs. He is asking for your help to reconstruct his setting in Rhino so he can show it inside the presentation of the show. The setting is made up of a table and 4 chairs. 2 of them are 3D printed and 2 of them are not. As for the dimensions of the setting, for the chair you have a dimension of 50 cm by 50 cm between the legs of the chair, and the legs of the chair have a dimension of 5 cm by 5 cm and height of 60 cm. The back of the chair is 70 cm. Now for the table has dimensions of 80 cm by 90 cm between the legs. The legs are 5 cm by 5 cm and height of 90 centimeters. The top of the table has the dimension of 80 cm by 90 cm and thickness of 5 centimeters. Now let's try to construct this setting inside Rhino. We have to launch at first the Rhino application, then we choose New File and search for centimeters. We have 2 options for centimeter: large objects or small objects. Since our object is less in dimension than a truck, the truck has dimensions of 13.5 meters, so we have to choose the small object option. Before starting, we have to rename the file to, let's say, exercise 2. Now the name is changed into exercise 2. There's also a small hint that the leg of the table starts at 0.0 reference. So the starting point of this project is at 0, reference. As I said in previous exercises, there are 100 ways to construct an object inside Rhino, but you have to choose the best and the most efficient option or command. Now let's have a small vision about the given. So you have 2 3D printed chairs, you have 2 normal chairs, and a table with some decoration on it. And you have the reference point of this table to be 0.00 as a reference for the leg. Now, as you can see from the figure, that the table is made up of surfaces, and any 3D point is made up of horizontal and vertical surfaces. Now, let's start by constructing the base of the leg. Now, for me, I would prefer to enlarge one of the viewports in order to have a better vision for the model. So I would choose the perspective viewport. So I double click on the perspective word and it's enlarged. Now, since the table is made up of surfaces, the base of the leg should also be made from surfaces. So I go to the surface menu and choose my options. Let's try several options to create this base. Let's start from the first one. Let's start by the first one. It is surface from 3 or 4 corner points. I have to choose the first corner of the surface. Since the first corner is at 0.00 reference, I just type 0 and I press enter. Now my first point is located at 0.00 point. Now the dimension of my leg is 5 by 5. So I have to construct a 5 centimeter edge. So I type down 5, then I press shift in order to have a straight direction, and I press on the left click. Then I do the same procedure for the other side. So I type down 5, press the shift, and left click the mouse. I do the same thing for the third time. And the base is constructed. Let's try other options. Construct this base. Let's try, for example, the rectangular plane corner to corner. It's the same procedure, so I have to put the first corner to be at 0, 0. Then I have to enter the length and the width. Since the length and the width are equal, they are equal to 5. So I have to insert the first 5 and press enter. Then I have to insert the other 5 and press enter. This is the second method. The third method is by 3 points. So I have to start the edge at 0. Then I have to construct the end of the edge, which is at 5 centimeters. I type down 5, press the shift, then the left click of the mouse. Now I have to insert the width, which is also 5. Now I have to choose the direction of my surface. So I press shift in order to have a straight direction, and I tilt my shift to be horizontally. Now I created the base line by the third option. Let's see if there's another option. You can construct this base by this option, which is 2, 3, or 4 edge curves. So you have to construct a minimum of 3 curves in order to construct a square. So you choose the polyline or a straight line option. Let's say I want to choose the polyline. I set my starting point of my polyline at 0. Then I construct a straight line at 5. I construct another line 5. Now I have like an open square. I go to this command and choose my 3 open curves, and I press enter. So this option is tricky because it doesn't work always. So for example, I chose the 3 sides and I ended up constructing a triangle. So I don't think this is the best option. So let me construct the base by using this one from corner to corner. So this is the base of the leg. Since I constructed the base of the leg, now it's time to construct the faces of the leg. Now the base is constructed in a horizontal plane. Inside the viewport, the faces should be constructed in a vertical plane. And the best way to construct a vertical plane is to choose the option of the vertical plane. It is telling me to choose the starting point of the edge. So the starting point is any corner on the space. So let me choose, for example, this corner. And the end of the edge is the adjacent corner. So you can choose this corner or this one. Let me choose this one, for example. And then I have to write down the height of my leg. In the given, it is 90 centimeters. So I should type down 90, press enter. The next step is to choose the direction or the position of the leg. I want my leg surfaces to be upwards. So I select or choose this option and left click the mouse. Now the first face of the leg is constructed. In order to have a better vision for this leg, I would recommend to choose the shaded option in order to have a better vision. Now I have to do the same procedure for the other faces to construct the 4 faces. So I choose the vertical plane, choose the starting edge, the end edge. I could type down 90 centimeters, or I just can link the corners together. Let's construct the third side. and the fourth side. I could start from the top to the bottom by creating this surface, as long as I have a starting point for the edge and an end point. So these are the 4 faces. Now I constructed the first leg of the table. The other leg is away from the first leg by 80 centimeters. So I should have like a reference point 80 centimeters away in order to construct the second leg. The first option that I could do is that I could place a point on this corner of the leg and move it by 80 centimeters. I type down 80, press the shift, and then left click the mouse. Now I have the first reference corner for the other leg. I could do the same thing that I did for this leg. I could create a base point here, and this point, for example, would represent the 0, 0 point. So the first corner is this point. Then I construct a base of 5 centimeters by 5 and reconstruct the faces. So type down 90, choose the direction and recreate the faces. So this is the second identical leg, and the distance between them, let me check, is 80 centimeters. So our work is correct. Another method to create the other leg is by using the copying command. So let's try it. First, let me select all the faces and delete them, but keeping this reference point. This reference point resembles the reference point of the first one, which is the 0.0 point. So what I would do is that I would select the faces, then I type down copy. Now I have to choose the point to copy from. I would choose the reference point of the first one, which is the 0, 0. I drag the second leg and I place both points on each other. So now I created the second leg using the copying method. There's another method using the copy command. Now, as we know that the distance between the 2 legs is 80 centimeters and the face of this leg is 5 centimeters. So the total distance of the reference point to the reference point of the other one is 85 centimeters. So let me first delete everything here. So we have this leg present in this viewport and nothing more. What I would do is that I would select everything in this leg and type down copy. Then I would choose the reference point, which is the 0, 0. Then I would type 85. I press shift and I place down my leg using the left click of the mouse. So if you want the distance between the legs to be 80 centimeters, you should type down 85 centimeters. And if you want the gap to be 90 centimeters, for example, you should type 95 because the face is 5 centimeters. So you have to subtract the face from the total distance. So this is the third method to create the other leg. Now let's use the same methods to create the back legs. So let us create the third leg. So the distance between this leg and the back leg is 90 centimeters. So I could just select this leg, I copy, choose the reference point to be the 0, 0 point. Then I could type 95, press the shift unit and left click the mouse. Then press enter. Now the third leg is created using the third method of the copy. Let's check the distance if it's correct. The distance is 90 centimeters, so it's correct. Now for the fourth leg, I would like to construct it using the reference point method. So I want to create like a reference for my distance. So I could place the point at this corner or at this corner. It doesn't matter. But I would choose this corner, for example. Then I want to select this point and move it 90 centimeters away. So I type down move. I select the point and type down 90. I press the shift in order to have a straight direction and I left click the mouse. So now I created a distance of 90 centimeters. And this point is the corner of my fourth leg. So what I would do is that I would select this leg, I would type down copy and place this corner on my reference point. So this is how I constructed the fourth leg using the reference point method. Now let's check if the distance is correct. So I go to dimensions, I choose linear dimension, choose the first point and the second. And yes, it is 90 centimeters. So my work is correct. Now I have to construct the top. And using the 4 legs, I have the corners of my top. So I choose any surface I want. For example, let me choose this option, which is surface from 3 or 4 corner points. I have to choose the first corner. So I could choose any corner to start. So I would choose, for example, this corner to start. My second corner is the edge of the leg. My third corner is also the other edge of the leg. And my fourth one is here. So this is how I created the base of the top of the table. So now let's construct the top of this table. The top of this table has the thickness of 5 centimeters. So we should construct bases having 5 centimeters in height. So we go to the surface list and choose the vertical plane. Then we have to choose the starting point of the edge, which is any corner of this top. Let's say I want to choose this corner. Then the end point of this edge is the adjacent corner. So either this one or this one. So I will choose, for example, this corner. Then it's telling me to choose the height of the face. So I will choose 5 centimeters. Then I press enter. I have to choose the direction or the position of my face. I want it upwards. So I left click on the mouse. And I have to do the same thing for the other sides. Choose the starting edge, the end edge, and I link both corners together. Same thing for the third side and the fourth side. Since I have the starting point of the edge and the ending point of an edge from the top, I could start from top to bottom, or I could do it like the ones before, from bottom to top. So now I have the sides of the top of the table. Now, in order to create the surface of the table, I could just select this bottom, type down copy, choose the reference point, this point, and copy it to the surface. So in this way, I created the surface of the table. Now, we constructed an useless surface, so I just will delete it. Now the table is done. Now you can use the other method to create the surface of the table by creating any surface. Let's say I want to create a rectangular plane, 3 points. I choose the first point, the second point, and the third point is any point on the edge of the surface. It could be also created in this way. Now, after we constructed the table, it's time to construct the 3D printed chair. The 3D printed chair is made up of curves. So let's start by creating the base of the leg of the chair. So the base is a curve which is a square and with diameters of 5 by 5 centimeters. Now before starting the construction of the base, we should put a reference point for this base. So we have to choose a point. Let's say I want a reference point to be at this point. Now I go to the rectangle. I can choose any option. Let's say I want to choose the corner to corner option. Now the first corner of the rectangle should be my reference point. Then I insert the length and the width of my base. So I insert 5, then I press enter, then another 5. So the base of the leg is created. I can create the base in other ways, such as using other forms of rectangles, such as 3 points, where my first point should be at the reference point. Then I type 5, I press the shift, and then I left click the mouse. Then I type another 5 and press enter. Then I have to choose the position of my square. So I keep on pressing the shift and I choose a horizontal position and I press enter. So this is another way to construct a square. A third method to construct a square is by going to the polygon menu and choosing square edge, where the starting point of edge is our reference point. Then I press on the shift and just type 5 and press enter. And my square is ready. Since we constructed the base of the leg, now it's time to create the faces of the leg. This procedure is the same as the legs of the table. So we go to the rectangle menu and choose the vertical command. It's the same as the vertical plane. You should choose a starting point for the edge, which is the corner of the square, and the end of edge is the adjacent corner. And the height is 60 centimeters. So you type down 60. Left click on the mouse and the first face of the leg is created. Now you do the same thing for the other faces. So you choose a starting point for the edge, an end point, and you link the corners together. Now the first leg is created. Now, in order to create the other leg, you select this leg, you type down copy, you choose the reference point as a copy point, you type down 55, and then you press the shift. After you press the shift, you left click on the mouse, then you press enter. So we created a duplicate for this leg. This is the second leg. You can also choose any method you want, any copying method you want. You can also put a reference point. You can do anything. But in Rhino, you should be smart. So you should choose the fastest way in order to create an object. Now, since the other legs are also identical to those legs, you can copy both of them at the same time in order to create the other two legs. So what I would do is that I would select both legs, type on copy, choose the point to copy from, which is this reference, and also type down 55 in order for the gap between the legs to be 50 centimeters because the face of the leg is 5 centimeters. I press on the shift in order to have a straight direction and I left click the mouse. Then I press enter to end this command. Now, as you can see, I created 4 legs in a simpler way and in a faster way. Now, after creating the legs of the chair, it's time to create the seat of the chair. So, as you can see in the figure, the seat is made up of a curve, mainly a square. So you can construct this seat either by this option, which is rectangle, or go to the square option. I would choose this command, rectangle corner to corner, where I choose the first corner. For example, I want to choose this one, and I will choose the other corner, which is its opposite corner, and the seating is created. Now the back of the seat or the chair is 70 centimeters. So you have to create a vertical curve. So you go to rectangle and choose the vertical option. You choose the start of the edge to be this point and the other edge to be this point. And then you type 70 in the command prompt and press enter. You choose the direction to be upwards, then you left click on the mouse and the back seat of the chair is created. Now, as you can see in this figure, the bottom part of the chair is the same, but the back is in a different direction. So a better way to do another chair is to copy the similar part and place it any point here in the viewport. Let's say I want to place the chair here. Then I press enter, and now you can see that the bottom part of the chair is copied. Now you create the back of the chair in this chair or for this chair. So you go to the vertical command and you create a 70 centimeter back. So this is one of the fast way to create 2 duplicate chairs. Now it's time to create the normal chairs. It's the same procedure that we did to create the 3D printed chairs, but at this time we have to use the surface option because the chairs are made up of surfaces. So the first step to do is to choose a reference point for the base of the leg. So you can choose any random point in the viewport. Let's say I want my reference point to be here. Then I go to the surface menu and choose an options to create my surface base. Let's say I want to choose this option, the corner to corner option. So my first corner of the plane is at my reference point. Then I have the leg is 5 by 5 centimeters. So I type down 5 for the length, the base. Then I type 5 for the width of the base. Now I created the base of the leg. Now I have to create the faces of the leg as I did in the table and as I did in the 3D printed chairs. So I go to the vertical plane option inside the surface menu. I choose a starting point for my edge, which is a corner of the base. Then I choose the end of the edge, which is the adjacent corner. Then I choose the height of 60 centimeters. I press enter. I choose the direction of the face, which is upwards, and I left click the mouse. The same thing for the other sides. So I choose the vertical plane, I choose the edges, and I link the corners. Then I select everything. I type down copy. I choose this corner. And since the distance between the legs is 50 centimeters, I should type down 55. Since the face is 5 centimeters and it's included in the total distance. I press down shift in order to have the right direction, and then I left click the mouse. Then I press enter to end this command. So now I have the two legs. Now I would do the same thing that I did with the 3D printed chair. So I would select both legs, type down copy, choose the point to copy from, and since the distance is also 50, so I would type 55. So if the face has a dimension of 10 centimeters, I would type down 60 centimeters. But since the face is 5 centimeters, so I will be writing 55. And the other set of the legs are created. Now I have to create the seat of the chair. So I could select any surface I want. Let's say I want to choose the rectangular plane 3 points. I choose a point to be my starting point of the edge. Let's say you can choose any corner. Let's say I want to choose this corner of my 4 legs. I choose the other corner, which is adjacent to it, and the third point, because I'm choosing the rectangular plane 3 points. So the third point would be at this corner, and the seat is created. Now I want to create the back. The back is vertical with respect to the seat. So I would choose the vertical plane, choose the starting edge, the end edge, type down 70 because it has a height of 70 centimeters. I have to choose the direction. Then after choosing the direction upwards, I left click on the mouse. So now my real chair or the normal chair is created. So now let's create the other chair. Since the other chair is identical to this one, the fastest way is to copy this chair to the other side. So first let's start by putting a reference point on this side, anywhere in the viewport. Let's say I want to put my reference point here. Then I select everything in this chair. I type down copy. I choose a reference point for copying. Let's say I want to choose this corner. Then I place both reference points on each other. Then I press enter to end this command. Now I created a double for my chair, but the back of this chair is directed in a different direction. So what I would do is that I would delete this face and create a new one towards the direction that I want. So I want the face to be here. So I create a vertical plane on this side. So I choose a starting point for the edge and an end point. I type down the height that I want. I want 70 centimeters as height. I press enter. I choose the direction and my chair is done. So I created the set of 4 chairs and the table. Now, if we look closer at the set, we can see that the seating of this chair and the back of this chair don't have any lines. So since they don't have any lines, this means that they are meshes. So I have to transform them into a mesh. So I select 2 and I go to the mesh option. I either choose the first button or this one, it's the same thing. And this is responsible for transforming surfaces into meshes. Now, since it doesn't have any lines, so I have to choose the option which is fewer polygons. I press OK. Now the meshes and the surfaces are above each other. So I have to click on this item and select the surface and delete it. I do the same thing for the back. I left click on this item, I choose the surface and I delete it. Now, as you can see, the seating and the back don't have any lines in the middle. This is because there are meshes. Now, as you can see in the figure, the same thing goes for the legs of the table and the legs of the chairs. So I have to transform all these surfaces into meshes. So what I would do is that I select all the legs and press this point or this button. Since they don't have any line in the middle, so I have to choose the fewer polygons. I press OK, and now I have to delete the surfaces. As you can see, I'm cleaning up all the surfaces on the legs and keeping only the meshes. Mesh. So you zoom in and zoom out in order to see better. So I'm deleting all the surfaces that are present. Leaving only the meshes. So now all the legs are made up of meshes. Now it's time to construct the mirror on the wall. In the given, we can see that the mirror is 100 centimeters above the floor and has an outer radius of 100 centimeters. And it's located in the middle of the wall. So the first thing to do is to locate this mirror at 100 centimeters above the floor. We can do this either by constructing a vertical line of 100 centimeters or construct a reference point at 100 centimeters above the floor and in the middle of the surface. So let's construct a vertical line this time as a reference. So the only option under the line list is this one. This is the only vertical option. So now I want to create a vertical line of 100 centimeters as height. So now I have a curve of 100 centimeters present on the surface. The second step is to construct the mirror. Since the mirror is on the vertical wall, I have to create a vertical circle. So under the circle list, the only two options that I have are these two, because these two are responsible for constructing vertical circles. And since I know the radius of my circle, the best option is to choose this button. Now I have to choose a center for my circle. I could choose any point. I would choose the end point of my line. I type down 100 and I left click the mouse. So my mirror is created, but it's stuck on the floor. So I want to elevate it by 100 centimeters. So what I would do is that I would select my mirror, type down move, choose my point to move from, which is this point, and intersect it with my endpoint of the line. So now my mirror is 100 centimeters above the ground. Now I have to construct the inner circle, but I don't know the radius or the center of the circle. So what I would do is that I would create the center of the circle by creating the diameters circle, and the intersection of the diameters is my center. So now I have my center. Since I don't know the radius of the inner circle, you can put any radius you want. So I'm gonna choose this option, the vertical option, choose my center, which is the intersection of the diameters, and type down any radius you want. Let's say I want a radius of 70. And now my mirror is created. Now let's decorate the table. On this table, you have 2 candles, a circular shape decoration, and a trapezoidal sheet. Let's start by constructing the trapezoidal sheet. So the first thing to do is to construct a random surface that has the same shape. Let's say I want to construct this sheet. Now I have to convert this surface into a mesh. Then I have to choose how many polygons do I want this mesh to have. Let's say I want this much, and I press OK. Now the surface and the mesh are above each other. So I have to select the surface and delete it. Now what is remaining is the mesh. Now I have to apply the mesh on the table. So what I would do is that I would select this mesh or the sheet and apply this command, which is apply mesh UVN. Now I have to select the surface to apply the mesh on. So my selected surface is this one. So now as you can see, this mesh or the sheet is applied on the table. Now the second thing that is on the table is the candles. Let's say each candle has a dimension of 3 by 3 centimeters and height of 15 centimeters. So the first thing to construct is the base of the candle. So I would choose, for example, this option, 3 points. I choose a reference. Let's say I want this reference, then I would type down an end of an edge, which is 3 centimeters. I press on Shift to have a straight angle, and I create the first side of my candle. Then I type down also another 3, and the base of my candle is formed. Now I have to do the faces of my candle. So it's the same thing that I did for the legs of the table and for the legs of the chairs. So I go to the surface menu and choose vertical plane. I choose my starting point and my end point. I wanted to have a height of 15 centimeters, and this is the first side. I apply the same thing for the other sides. And my candle is ready. Now I have to move it somewhere else other than the corner of the table. So I select all the sides, including the base, and then I type move. I choose a point to move it from. Let's say I want to move it from this corner and choose another point. Let's say I want to put it on the corner of the sheet. So I place it here. Now I want my other candle to be on the other side of the sheet. So what I would do is that I would select it again, including the base, type copy, choose a copying point and place it on the other corner. Now I have 2 candles on the table. Now I want to create the circular shape at the middle of the table. So what I would do is that I want to create the center of this table. So what I would do is that I would take the middle of the table, draw some diameters, and their intersection point would be the center of the square. So now I would construct a vertical circle having its center at this point, and then I choose a random radius. Let's say I want to have my decoration with 10 centimeters. Now my circle is inside the table. I want to elevate it to be adjacent to the table. So I would select my circle, type move, choose this point of the circle and put it at the center. So now I have the decoration at the middle of the table. Now I would delete the unused items. For example, this mesh, I don't need it anymore. And I have my setting drone, and Rhino. Thank you so much for watching this video, and please don't forget to watch other videos in order to become pros in Rhino. See you in the next video. In this video, I will be testing your knowledge about topics I discussed in previous videos. Let's play true or false. In this game, you will have 10 seconds to answer the statements and the questions before I reveal the answers later on. So let's begin. Question number 1. Is a closed curve considered a polygon, true or false? Time is up. The answer is true. Why? Because by definition, a polygon is a closed curve shape. So any closed curve is a polygon. As you can see from the figures below, both figures have the same structure. Question or statement number 2. A mesh cannot have quadrangulated and triangulated faces together. True or false? The answer is false. Both types can be present in the same mesh. For example, complex meshes have both types inside the same mesh. Another example is that if you delete mesh faces, then repair the hole, you'll have triangulation. Also, you can have both of them if you collapse some parts of a mesh. Question number 3. A surface is made up of lines. True or false? Time is up. The answer is true. A surface is made up of a closed polyline and some lines from the inside. The borders of the surface are considered closed polylines, and polylines are lines, and make up the imaginary surface. And from the inside, the surface is made up of set of lines and curves. Question or statement number 4. A surface can be covered with a mesh. True or false? Time is up. The answer is true. If we apply the mesh UVN command, the mesh will appear as a skin on the surface. For example, we have this mesh and we apply the mesh UVN command. This mesh will cover the surface and also this mesh will take the form of this surface. Question number 5 or statement number 5. A mesh is made up of points. True or false? Time is up. The answer is true. Why? Meshes are surfaces. Surfaces are made up of lines. Points form lines. So meshes are made up of points. Question number 6 or statement number 6. C-plane is only effective in the grid. True or false? Time is up. The correct answer is false. A world axis doesn't have limits, and the C-plane is considered as a world axis. The grid is only for measurement purposes. Statement number 7. A mesh can be transformed into a surface. True or false? Time is up, and the correct answer is false. It is false because only surfaces can be transformed into meshes. This is an irreversible procedure, so you can convert a surface to a mesh, but you cannot convert a mesh to a surface, unless you have like a complicated plugin, but in normal Rhino software you cannot. Statement number 8. An ellipse is a deformable circle. True or false? Time's up, and the answer is false. A deformable circle, by definition, is a circle that don't have any radii equal to each other. So it's like a sketchy circle with no dimensions. An ellipse has equal radii. It is a circle with elongated sides. So you have two axes, the x-axis and the y-axis. The radii of the x-axis are equal to each other and the radii of the y-axis are equal to each other. Statement number 9. An object in the viewport has the same axis as the C-plane. True or false? Time is up. The correct answer is true. The C-plane is the world axis. So all objects inside this world would take the same axis as the C-plane. So in this figure, you can see that the x and y of the C-plane are the same as the x and y of the object that are selected. And both axes have the same direction. This is everything related to this exercise. Thank you for playing this small game, and don't forget to watch the next practical exercise.
Hi there! Congratulations on coming this far. I hope you're enjoying the course and already starting to see some results. If you like the tutorial so far and want to check out the extended version of the course, head to skillademia.com, where you will find our full Rhino Beginner to Advanced course with more than 50 lectures and many more projects to complete. Now, let's continue.
In this video, I will be discussing how to construct solids. Solids are a 3D object in Rhino, and they are present under this button. You can find shapes such as cubes, cylinders, pyramids, and many more. Let's start exploring some of them. The first option is a box. With this command, you construct cubes, rectangular prism, or any rectangular shaped object. Inside this button, there's a list, and there's like 4 options to create this box. The first option is corner to corner and height. So you place your first corner of this box, then the second corner. You can also type the length and the width like we did in the surfaces and the rectangle. Let's say I want to put a random point at this moment, and then you type down the height. For example, you want a height of 50 or 5, then you press enter. Now, as you can see in the top view, you can see only the cube shape or the square shape, and the front and the right you can see the height, and in the perspective view you can see the whole box. So that's why I prefer to work in the perspective view, because I can see the overall result. Now another option is creating a box by diagonal. So it is asking me to put the first corner, then the second corner is the diagonal. As you can see like a white line defining my diagonal. You can type down a measurement for this diagonal. For example, you want a diagonal of 10. And then you left click on the mouse, then you type down the height that you want. Say I want to put it 5. And also the height is defined by the diagonal, as you can see. The third option to construct a box is 3 points and height. So you choose a point for the starting of the edge and a point to end this edge, and you press shift in order to have a right angle. And then you either choose a third point or you type down the width. Let's say I want a width of 4. you left click the mouse, and then you choose the height. So this is the third option to create a box. The fourth option is box center corner height. I have to choose a center for the base, let's say this point. Then as you can see, I am creating a square around the center. Let's say I want a length of 5 and the width of 10. Now I have to type the height, 50. And I created the fourth type. Now, in order to see those boxes in a better view, I recommend to change the viewing type to shaded. So now you can see the boxes in a better way. There's other options inside the box. Now, under the box section, there's an option called bounding box, but I leave it for later in order for you to understand it better. Let's move to the cylinder option. The cylinder is just straightforward. There's no types of cylinders. So it's telling me to choose the base of the cylinder. Say, I want this cylinder to have a radius of 20. I left click the mouse and then I choose the height of the cylinder or the end of the cylinder. Let's say I want this cylinder to have a height of 20. I type down 20 and I press enter. Now my cylinder is created. There are many options to create a cylinder, but they are not present here in this list. All you have to do is to press on the cylinder button and choose your options from here, from the command prompt. Let's say I want to create this cylinder from 2 points. So it's telling me to start the diameter at a certain point, let's say at this point. And I have to choose the other point. So you can type down a number or you can place it manually. Say I want to have a 20-meter diameter. Then I choose the direction of my cylinder. Let's say I want to put it here. Then I type down the height. You can choose also other options such as 3-point, where you create this cylinder by 3 points. So you have to choose the first point. Let's say I want my first point to be here, my second point to be here, and as you can see, you can put a third point anywhere you want, say here. And then also you type down the height. Let's put the same height as the other cylinders, which is 20. But right now, the 20 is upside down, so you should type -20, and the direction will be shifted upwards. Let's try other options, such as tangent. So you have to have a curve. Let's construct a curve, any curve you want. Try several curves. So I created this cylinder, which is tangent to this curve and the other curve that I drew on the other cylinder. And the final option is to fit this cylinder into several points. Let's create some points, then select them, then create a cylinder through these points. This is how you construct cylinders inside Rhino. Now let's try other solid options. Next we have creating a sphere. There's a list inside the sphere option where you can choose several ways to create a sphere. Let's start by the first one, which is creating a sphere by a center and specifying the radius. The first step is to place the center of the sphere anywhere in the viewport. Let's say I want to choose this point. Then I have to specify the radius. Let's say I want to choose a radius of 20. Then I press enter and my sphere is created and has a radius of 20 meters. Another option is creating a sphere by diameter, where I have to start the diameter at a certain point in the viewport. Then I have to type down the measurement of my diameter, or I can place any point inside the viewport. Let's say I want the diameter of 40. Then I have to choose a position for my sphere. Let's say I want the sphere to be located here in this position. And I created my other sphere. A third way of creating a sphere is by 3 points, where you choose your first point, you choose your second point, you can also type down, and once you type down a number, you are specifying the diameter, so it's like this option. And then you choose your third point. For this third point, you can also choose a radius, so it's like creating a sphere with different focal points. Let's say I want a radius of 20. Then you place the points together at a certain point, and your third sphere is constructed. A fourth way to create a sphere is by setting up 4 points. So let's say my first point is here, my second point is here, my third point is here, and my fourth point, I want my fourth point to be, it's only working if the third point and the fourth point intersect each other. Let's try it again to see if there's anything. So it's not working unless the last 2 points intersect each other. So this is how you create a sphere by 4 points. So the third and fourth point should be on each other. Another option to create a sphere is around the curve. So let's say we have this curve and I want to create a sphere around this curve. So what I would do is that I go to this option and select my curve. Then I have to choose a point on this curve. Let's say I want to create my sphere at this point. So this point will be the center of the sphere. Then I choose a radius. Let's say I want a radius to be 10, and I press enter. Now my sphere is intersecting this curve at a certain point, and this point is the center of the sphere. Another option is tangent from circle tangent to curves. So I have to choose a first tangent curve. Let's say I want my sphere to be tangent at this point. Then I create a second tangent with a radius for the circle. Then I choose the third tangent curve, or like the orbit of the sphere. And the fifth option is created, because as you can see, the sphere is made up of horizontal circles and vertical circles. So what we did is that we defined the horizontal circles and the vertical circle, and we made it tangent to this curve. The fifth option is creating a sphere through points. So let's scatter some points in the viewport, then select them and choose the last option. So now I made my sphere fit inside those points. 7 options to create a sphere. Now if you open the solid list, you can see that there is a sphere option with list inside of it, and there is also a sphere by diameter outside the list. This option is also present in the list, which is this one. But the reason why it's placed outside, because this is the most frequent option to create a sphere. So in order to facilitate the selection process, it is placed outside. Now let's move to another solid, which is the ellipsoid. Inside this ellipsoid, there are 5 options to construct this ellipsoid. Let's start by the first one, which is ellipsoid from center. So the first step is to choose the center of this ellipsoid and then choose the first radius of this ellipsoid. Ellipsoids have 3 axes or 3 directions. So this is the radius of the first axis. Let's say I want a radius of 20. Then I have to set the radius of the second axis. Let's say it's 10. And the third axis is responsible for the height of this ellipsoid. So I want to put a height of also 10. Then I press enter and my ellipse is created. Another option to create this ellipsoid is by diameter. So the first thing to do is to set the diameter of the first axis. Let's say I want a diameter of 20. The second axis has a diameter of 40. And the height of the ellipse is 10. So this is the other ellipsoid. The third option is to construct an ellipsoid by focal points. So I have to choose a point for the first point of the focal point, and then I have to choose another point, which is the other focal point, and then I have to choose the width of my ellipsoid. This is the third option to create an ellipsoid. The fourth option is creating ellipsoid by corners, where you set up the first corner, then you choose the opposite corner for this first point, and then you choose the height of the ellipsoid. Let's say I want it to be also 10. This is the fourth option. And the fifth and the last option to create an ellipsoid is around a curve. So let's construct a curve, then go to this option, select our curve, then choose a point on this curve to be the center of the ellipsoid. Then we have to choose the first radius of the ellipsoid, the second radius of the ellipsoid, and the third radius or the third axis of the ellipsoid. So now we have this ellipsoid which is intersecting this curve at a certain point, and this point is the center of this ellipsoid. So these are the 5 options to create an ellipsoid. Now, other options present under this solid list are the paraboloid and the cone option. Let's start with the paraboloid. Paraboloid is a parabola in 3D. The first thing to do is to choose the peak of this paraboloid. Then you have to choose the length of this paraboloid or the height of this paraboloid. You can choose any point in this viewport. After that, you have to choose the wideness of this paraboloid. After choosing a point, this paraboloid is ready. It looks like the tip of the bullet. So this is how you create the shape of the tip of the bullet. Let's try the other option, which is the cone. So it's telling me to choose or to start by constructing the base of the cone. I choose a circle of any radius. Let's start by putting a radius of 20. Then I have to choose an end for this cone, which is the height of this cone. Let's say you want this cone to be at 50 meters high. So you created a cone with height of 50 meters. Let's try another option, which is the truncated cone. It is a cone, but not having the sharp edge at the top. So it's the same as the cone. We should start by creating the base of the cone. Start by creating a radius of 20. Then I have to choose the height of the cone, which is, let's say, also 50. And then I have to choose another radius for the top of this cone. Let's say I want the radius to be 10. So this is how you create a truncated cone. It's like this cone, but as if it's cut. Now it's time to construct a pyramid. So there is a button called pyramid, and it's responsible to construct a pyramid. Now you have to insert a center for this pyramid. Then you have to choose how many sides you want this pyramid to have. You can put any number. Let's say you want this pyramid to have 3 sides. Now this pyramid has 3 sides. Then you left click on the mouse, and then you insert the height of the pyramid that you want to have. I want this pyramid to have a height of 40 meters, and the pyramid is created. Let's create another pyramid having 5 sides. So I go to the number of sides and change 3 into 5. Then I choose a center. Then I choose the height of my pyramid. Let's say also 40. And now I created a pyramid with 3 sides and another pyramid with 5 sides. Another option under this list is the truncated pyramid. It's the same as the truncated cone, so it's a pyramid cut at a certain point. It's the same thing as the pyramid, so you should start by creating the base of the pyramid. Let's say we want this truncated pyramid to have 5 sides. And then you choose the height of this pyramid, say also 40. And then you choose the upper radius to be any number you want. Let's say we want this upper radius to have a dimension of 20. So now you created a truncated pyramid. You can choose any number of sides for this truncated pyramid. So let's try it with the 3 sides too. So let's change the number of sides into 3. Choose the height of the pyramid, which is 40, and then choose the top radius, which is 20. Now let's construct other solids, such as the tube. A tube is mainly a cylinder, but has a void inside of it. So the first thing to do is to create the base of this tube by choosing a random point in the viewport, creating the first radius of this tube. Let's say our first radius is 10. And then we have to create the bigger circle. Let's have this circle to have a radius of 40. And then we have to choose the height of this tube. Let's say this tube has a height of 100. Then you press enter, and this tube is created. Another solid is the torus. The torus is mainly known for the donut shape. So let's create a donut. The first thing to do is to choose a center for this torus. Let's say this torus has a radius of 20. Then you have to choose the radius of the circles that's forming this donut. So the second radius is, for example, oh, it's too much. Let's say it's 10. Then you press enter, and your donut or the torus is formed. Now we're going to talk about the pipe flat caps and the pipe round caps. In order to create a pipe, you should have a rail. A rail is any curve that you draw inside the viewport. So let's create a curve. For example, this is the rail. So I go to the pipe option and select my rail. The first thing to do is to choose the radius of the first end of this rail. Let's say the radius is 10. Then I have to choose the radius of the circle of the second end of the rail. It's also 10. You can put different radiuses, but I'll keep on putting 10. Now, after creating circles at both ends, you press on enter, and now you constructed a pipe. And this pipe is around the curve that you created, or the rail that you created before. So if you look at the end of the pipe, you can see that the end is flat. Let's do the same thing for the other option, which is round caps. We have to create a rail. Then we have to select the rail, choose a radius for the first circle, and choose a radius for the second circle. Then press enter. Now, if we want to compare both ends, you can see that the end of this pipe is a rounded shape, and this one is a flat shape. So this is the difference between a pipe with flat cap and pipe with round cap. There are 3 other more options in the solid list, but I don't want to talk about them at this moment. I'll keep them for later. So basically, this is everything about solids. Thank you so much for watching this video. Don't forget to watch other videos and be pros in Rhino. In this video, you will be practicing solids in an exercise. So let's see the given. The artist of the gallery show in the previous exercise provided us with new information to add them into the Rhino file. He told us that the show is taking place in Egypt, and the pyramids are 70 meters away from the setting. He also provided us the measurements of the pyramids. Pyramid 1 has an edge of 2000 centimeters and a height of 1000 centimeters, and the upper radius is 100 centimeters. Pyramid 2 has the edge of 5000 centimeters and height of 2000 centimeters. Pyramid 3 has an edge of 3000 centimeters and a height of 1500 centimeters. Pyramid 1 is 1000 centimeters away from Pyramid 2, and Pyramid 2 is 2000 centimeters away from Pyramid 3. So let's start by constructing the pyramids. Now let's open the previous file, which is this one. The first step to do is to draw a reference from the location of the setting to the pyramids. So the distance is 70 meters. But since we are working in centimeters, so we have to convert the 70 meters into centimeters. So 70 meters is 7,000 centimeters. So what I would do is that I would create a line which is 7,000 centimeters. So at this point, the pyramids will start. Now the first pyramid has a dimension of 2000 centimeters as an edge. So each edge inside this pyramid is 2000 centimeters. Now we have to choose the pyramid option. Now if we choose this point, this will be the middle of the pyramid. So if we type down 2000 and we construct this pyramid and we measure the edge, it won't be 2000 centimeters. So what should we do? The solution is to go to the pyramid button and go to the command prompt for more options and click on edge. Now my starting point of my edge is this point, and then I have to type down 2000. I press the shift in order to have a right direction and I place the point. Then Our height is 1000 centimeter. So I type down 1000 and the first pyramid is done. But our first pyramid is the truncated pyramid. So I have to redo it again and choose the option of truncated pyramid. The same thing is present in the command prompt for the truncated pyramid. So there is an edge option. So I choose it. I choose the starting point of my pyramid. I type down 2000. Then I type down the height, which is 1000. And the top radius is 100. And this is how I constructed the first pyramid. Now let's construct the second pyramid. The second pyramid is 1000 centimeters in front of pyramid 1. So we have to create a reference line of 1000 centimeters. Go to the pyramid section, choose the edge option and type down the edge of the pyramid 2, which is 5000 centimeters. Then I would type down the height of this pyramid, which is 2000 centimeters. And the second pyramid is created. Now the third pyramid is 2000 centimeters away from pyramid 3. So I would take a distance of 2000 centimeters and construct pyramid 3, which has the dimensions of 3000 centimeters per edge and 1500 centimeters in height. So this is my reference point. So I want to choose the edge option, choose the starting point of this pyramid, type down 3000 and 1500 by height. So these are my 3 pyramids. Let's double check the edge dimension. So the first pyramid is correct, is 2000 centimeters. The second pyramid should be 5000 and it's correct. The third pyramid is 3000. Let's see if it's correct. It's correct. Now after we finish constructing these pyramids, you can just delete your reference lines, leaving all the pyramids alone. So this is how I constructed the pyramids. There are many ways to construct cones. So you go to the solid menu, choose the cone button, and go to the command prompt. You can see that there is an option called 2-point, 3-point, tangent, and fit points. So let's construct the fourth cone by the 2-point option. It is telling me to choose or to state the diameter of my cone. Since the radius is 200 centimeters, then the diameter is 400. So I choose a starting point for my diameter, then I type down 400. Then I choose the height of the cone, which is 400 centimeters. Then I press enter and my fourth cone is done. Now, concerning the fifth cone, it's placed in a different direction. So in order to create it, I will use the option of direction constraint. So I don't want my cone to be vertical. I have either none, vertical, or a round curve. Since I don't have a curve and I don't want it vertical, I just press none. Now I have to draw the base of my cone. Then I would direct it wherever I want. And now this is the different direction cone. In order to be at the same level with the other cones, I just move this cone to the edge of the last cone. Now this cone is still under the other cones. So in order to move the object in a vertical direction, what I would do is that I would type move, go to the command prompt and switch this option into yes. So I click on it and now it's transformed into yes. So now I could move my object in a vertical direction. This is the fifth cone. Now, in order to continue the series, I can just select these, type down copy, choose a copying point, which is this point, this edge, and move it here. Then press enter, and these are my cones. I created 5 and 4, 9, so I just need one more. So let me copy this one. So this is my fence, and this is how I created this fence. You can select all of them and move them a little bit in the viewport, and you delete this reference point, this reference line. Now let's see what's next in the given. A catering company wants to sponsor the artist stand, but in return, donuts will be placed on the table. As you can see, 4 donuts are placed on the table. Donut 1 has a radius 1 of 5 centimeters and radius 2 of 2 centimeters. Donut 2 have radius 1 6 centimeters, radius 2 2.5 centimeters. Donut 3 radius 1 4 centimeters, radius 2 1.5 centimeters, and donut 4 radius 1 equals to 3 centimeters and radius 2 equals to 1 centimeter. So as you can see, the donuts are not equal. Each donut have a measurement, and you decide which donut has which dimension. So let's start by constructing donut 1. So we go to the solid menu and choose the torus. I should place the center of this torus. Let's say I want it at this point. Then I choose the first radius, which is 5, and the second radius is 2. So this is the first donut. The second donut is 6 centimeters, radius 1, and 2.5 radius 2. So let's construct the other donut. Let's say I want to construct my donut at this point. The radius is 6 and the second radius is 2.5. Now I move my donut this way. The third donut has radius 1 4 centimeter and radius 2 1.5 centimeters. So I choose the torus again. Radius 1 4 and radius 2 1.5. And the fourth donut is the mini donut, which has the radius 1 equals to 3 centimeters and radius 2 equals to 1 centimeter. So let's construct the fourth donut. Now let's move it away from the edge of the table. Now, as you can see, the donuts are embedded in the table, so you have to elevate them a little bit. So all you have to do is to select all the donuts, type on move, and then choose this option to be yes. Now choose any point in the viewport and elevate the donuts a little bit. You can insert a value. Let's say I want to raise them by 2 centimeters. I type down 2 and then press enter. Now the donuts are raised by 2 centimeters. Now another good news is that another company wants to sponsor the artist stand. In return, a surfing board and a sports ball will be placed on the setting. The surfboard has a dimension of the first axis with diameter of 70 centimeters, axis 2 with diameter 150 centimeters, and axis 3 with 30 centimeters. So let's start by constructing the surfboard, and the items could be placed anywhere in the setting. So let's go to the solid menu and choose the ellipsoid, since the surfboard has an ellipse shape. Now we have to choose one option of the 5 options. I will be choosing the option by diameter, since in the given they are telling us information about the diameter. So I should place the first point of my surfboard. Then I should place the diameter of my first axis, which is 70 centimeters. And the first axis is placed. Now I have to type down the second axis, which has the diameter of 150 centimeters. Let's type down 150. And the third axis is 30 centimeter in diameter. So this is how I created the surfboard. Now it's time to create the sports ball. The sports ball has a spherical shape, so I want to create a sphere, and this sphere has a radius of 60 centimeters. So I would go to the solid menu and choose the sphere. Now I could choose the sphere by center and radius, and I could choose the diameter because I know that the diameter of the sphere is 120 centimeters. But let's stick on the center and the radius. So I pick any point on my setting and I type down 60. And this is how I created my sports ball. Now I have to move it upwards. So I type move and I change this option to yes. I choose a point from the ball and I move it upward. Now I have to move it horizontally. So I retype move and I make sure that this option is no. And then I move the ball wherever I want. So this is everything related to the other sponsor. Now, if you pay a little bit attention on the setting, you can realize that this artist made a slight modification to the mirror on the wall. The mirror right now has a frame. And in order to create this frame, you can use this option, which is the tube. Now, when you select this tube, make sure that you change this direction constraint into none, because this mirror is in the vertical direction and the C-plane is in the horizontal way. So if you create a tube without changing this one and keeping it vertical, the tube will be in a vertical direction. Now let's choose the base of the tube. The base of the tube is the center of the mirror. The first radius is the intersection or the tangent of the first circle of the mirror, and the second radius is the tangent of the second circle. Now, as you can see, this frame is moving freely, but we want it to have a horizontal direction. So in order to make this step easier, because it's kind of hard, so what will you do is that you open the 4 viewports. You double click on the perspective. Now you can see the 4 viewports and you go to the top view. You press shift and you choose how much you want this frame to be extruded. Let's say I want it to be this much, and I left click on the mouse while I am on the top viewport. So now if you go to the perspective viewport, you can see that the frame of the mirror is created. Now there's something that I want to add. The sponsor of the sports ball wants this ball to be wrapped inside a box. So he doesn't want this ball to be seen. In order to do so, you select this ball and you go to the solid option, to the box option, and you choose the bounding box. Then you press enter. Now, as you can see, this ball is wrapped inside the box. So this is the main purpose for the bounding box. This is the end of exercise 3. Thank you so much for watching this video, and see you in the next video. In this video, I will be talking about a toolbar which will make your job and the construction process easier. Yes, I admit that in the previous videos I was making things harder, but it's good to learn the easy way and the hard way. This toolbar is called the status bar, and it is present in the bottom of the Rhino file. So this is the status bar, and it includes the object snap control, which is present here. Now let's define every button inside the status bar. The first button is the C-plane. Every viewport has a C-plane, which is a horizontal plane. This plane has an x-axis and a y-axis. And every point in this plane has coordinates. So if I move my cursor from point to point, you can see that the x and the y values are changing. This is because these are the coordinates of the points present in this plane. Now, if I switch the C-plane into the world, then every viewport will have different coordinates. This is because every viewport has its own axis. For example, in the top view, you can see that there is an x-axis and a y-axis. So only the x-axis and the x values and the y values will change, and the z value will remain 0. In the front view, you have the x-axis and the z-axis, so the y value will be 0. In the right viewport, there is a y-axis and the z-axis, so the x value will be 0, and the y value and the z value will vary. In the perspective view, the same thing it's like the top view, so only the x and y values will change, and the z value will remain 0. Now let's explore other buttons or labels. Next to the x, y, and z coordinates, there is something called centimeters. This label is responsible to tell me which unit I am working on inside the viewports. So by looking at this button or this label, I could automatically know what unit I'm working with. Now, if I want to change the unit from, for example, centimeters into meters, this label will automatically change into meter. So there's no need to go to the tools, options, unit to see what unit you are working with. Just you could look here and see which unit you are working with. Next to the meter label, you have something called default. This button or label is used for layers. But since we don't know anything about layers, I prefer to leave it for later. Now, as for the grid snap, what is a grid snap? During any construction process inside the viewports, there is a huge difficulty to locate the starting point of a line. So let's say I want to start the line at this point of the square. It's very difficult to locate this point exactly at the intersecting point of the square. So if you turn on this grid snap and start a new line, you can see that the starting point is automatically selecting the corners of the squares. So it will make your job easier to draw lines, straight lines on the grid. Now, what is OSNAP? In the previous videos, while constructing some objects, I'm so sure that you realize that there are some annotations inside the viewports, such as near, end, int, not, mid, sen, quad, perp, and so much more. This is because the OSNAP is turned on. Now, if I turn off the OSNAP, no annotations will appear in the viewports. This is because the job of the OSNAP is to highlight for you the guides of measurements in an object. For example, it guides you where is the midpoint of this line, or where is the midpoint in this rectangle, where is the center of this arc or this circle, the tangent point of any object. So basically, it's guiding you to create accurate drawings in a faster way. Let's say, for example, I draw a line. It's so easy for me to locate the midpoint of this line using the OSNAP or the object snap. But if I turn off the object snap, it's impossible to locate the midpoint. Unless I do the calculations for the line, then I do the midpoint of this line, and it would take so much time. So Rhino is doing the job for us using this object snap. So thank you, Rhino. You can control what annotation you want to see inside the viewport while this object snap is turned on. You can control it by going to the Object Snap Control toolbar. This toolbar is present above the status bar, and it includes end, near, point, midpoint, center, intersection, perpendicular, tangent, quadrant, knot, and vertex. Now, what's the meaning of end? End is the end of a line. So this line has two ends, and those two ends have points. These points are called knots. So every line has two ends and two knots. Let's take, for example, this polyline. A polyline is made up of several lines. So this line has an and a not, another and a not. Now the intersection annotation appears. This means that this line is intersecting another line. The same annotation appears here because this line is intersecting this line. Let's take, for example, this rectangle. This rectangle is made up of 4 lines. The first line has 2 ends and it's intersecting other line. So that's why the annotation of intersection appears. Now the annotation of midpoints is appearing because I am pressing on the midpoint of this line. So Rhino is telling me that the midpoint of this line is at this point. Now, what is the near? Near is any point between, for example, the end and the midpoint, or the end and the not. You can say that between the midpoint and the end of this line, there is the annotation of near. The annotation of sen determines the center of the arc or the center of the circle inside the viewport. So now I could see that the center of this circle is at this point. Now, if I draw a parabola, you can see there are different annotations from not and quad. Quad is quadrant, so this is the quadrant of the parabola. So let's say I want to create a tangent point or a tangent line from this parabola. As you can see, a tangent annotation appears. So this is the main job of the object snap and the object snap control. Now, if you don't want, for example, the annotation of the midpoint to appear inside the viewport, you just uncheck this square. And now there is no way that the midpoint annotation will appear. The object snap control is present because sometimes you just want to locate the midpoint, for example, of this line. And by mistake, you just snap the near point. So this will lead to inaccurate drawings and the 3D model won't be coherent. So this is why we turn off and on the object snaps. Now let's move on and try the Smart Track button. Before we turn on this Smart Track button, let's draw a perpendicular line to this line. As we draw this line, no information is given to us. No height, no angle, nothing. You just have to fill the information that you want, the height that you want inside the command prompt. But if we turn on the Smart Track and draw the same line, same perpendicular line, you can see that it's giving you the angle, the status of this line, which is perpendicular to this line, to the horizontal line, and the dimension of this line. So at this moment, this line is 82 meters. Let's say I want to construct this line at 100 meters. So this is the right point to construct this line. Now, if we want to check the distance of this line, it's 100 meters. So it's accurate. So the Smart Track gives you more information during construction. Now let's move on to the gumball. What is a gumball? A gumball is an option that shows the axis of an object. You can adjust, move, or even rotate an object using this gumball. Let's demonstrate what this button can do. So let's turn on the gumball and enlarge the perspective view because I want to work in the perspective view. Now you can select any curve you want inside this viewport. I will select this one. As you can see, 3 arrows will appear. One is red, one is green, and one is blue. Now, the red represents the x-axis, the green represents the y-axis, and the blue represents the z-axis. Now, if you press on the red arrow and move, you can see that this line is moving in the x-axis direction. You can also left-click on this arrow and insert a value that you want this line to be moved. For example, I want this line to be moved by 20 meters. I insert 20 and my line is moved by 20 meters. Now, if I want to move my line to the opposite direction, I left click on this arrow and type down, for example, -40. And this line will be shifted in the other direction by 40 meters. Now, if I want to move this line to this direction, I use the green arrow. I can also insert some values. So this is an easier way to move a line instead of typing move and choosing a certain setting or the move option. Now, if you want to elevate this line upwards or downwards, you can use the blue arrow, and also you can insert a value, 40 for example, and this line is elevated by 40. Instead of typing move, select the object and changing this vertical into a yes, then moving the object vertically, you can use the arrows of the gumball. Now, also using the gumball, you can shrink an object. For example, I want to make this line shorter. There's a point here in the opposite direction of the arrow. You can left click on it and drag. Now you can see this line is shrinking in size. This is another option for the gumball. Now, besides the arrow, you can see that there are some lines having the same colors as the gumball. These lines are responsible for the rotation process. So if I want to rotate, for example, this line, what I would do is that I would click on this line and drag the mouse. Now my line is shifted into another direction. Now, if I want to create a vertical line from this line, I choose another line. And in order to shift this line vertically, this curve is responsible for this option. So what I would do is that I would press on this line and drag the mouse to reach the desired position. So in the previous exercise of the chair, in order to rotate the chair, we can just simply use the gumball. There is no need to copy the chair and then delete the back of the chair and redraw it again. So the simplest way is to use the gumball. You can copy the chair and then you can rotate it and the job will be done. So this gumball is very important in the Rhino construction and will save you time. The last button in the status bar is the record history. In the first video, I told you that everything you do inside Rhino is recorded in the command window. But if you don't turn on the record history and you save this file and reopen it again, nothing will appear in the command window the next time. But if you turn on the record history and you work inside Rhino, everything you do after you turn on this button will be recorded in the command window for later. So if you record anything in Rhino while turning on the record history, if you save and reopen this file later on, everything will be saved in the command window. So this is the difference between keeping the record history on and keeping the record history off. Now, the last label that is moving is the relationship between the Rhino software and your laptop or computer. So it's telling you some information about the CPU use, the physical memory, the absolute tolerance. So how this Rhino software is affecting your laptop or computer. So this is basically everything about the status bar and everything related to object snaps. Thank you for watching this video and don't forget to watch the next video related to layers. In this video, I will be introducing the layers. What is a layer? In order to understand its concept, I created an animation. In this animation, you have set of balls and set of sheets placed on the ground, and you have two baskets. One of them is labeled as balls and the other is labeled as sheets. So what I'm doing is that I am placing similar objects or objects that have the same properties in the same basket. So in this object here, we have similar balls placed in the same basket, and here we have the same sheets placed in the same basket. And this is exactly what is layering. It is when you organize the objects inside the viewport that have the similar form or properties together in a box. And this box is called a layer. Now, before I start everything related to layers, I want to recreate the table that I did in the previous exercises. But let's create this table using the new tools that we learned. So I want to create this table using the box menu. So as I remember, the legs of the table were 5 by 5 centimeters and height of 90 centimeters. And for the top of the table, it has a thickness of 5 centimeters. So the first thing to do is that I want to check the unit inside this viewport. So right now it's in meters. So I want to change the unit from meters into centimeters. The second thing I want to do is, instead of pressing the shift all the time, I want to make sure that the ortho and the grid snap are on, as well as the object snap. Now I go to the box menu and choose an option. I will draw the legs of the table using the corner to corner option. So I want my first corner to be at 0, 0. Then I type down 5, I press enter, then I type 5 and I press enter. Then I insert the height of the leg, which is 90 centimeters. So now I created the leg of the table. Instead of drawing each face alone and then linking them together, it's just a simple procedure to draw a box. Now let's create the other legs. I would select this leg and type down copy, choose a point of copying, and I would type down 55. No, let's say 55. Let's say the distance between the legs is 50. Now, I would copy these two also, choose a copying point, and then I would also type down 55. Now I created the legs of the table. Now it's time to create the top. I'll do the same thing. I choose a box menu, I choose the corner to corner, I choose the first corner, I choose the second corner, and the height is 5 centimeters. So I created this table for like just 1 minute. Instead of building all the faces and losing time, I think this is a much efficient way to draw a table. Now the reason why I drew this table is because I want to apply the layers on this table. At the bottom of the layer toolbar, there is a slide. This gives you access to other settings related to the layers. For example, you have light bulbs, you have locks, you have colors, material column, line type, and print width. What are the light bulbs for? The light bulbs are responsible to tell you which layer is on and which layer is off. For example, you know that layer 5 is on because its light bulb is on, and you know that layer 14 is off because its light bulb is off. In order to turn on the layer 14, all you have to do is to press on the light bulb. Once the light bulb is lit, you can see that the layer is on. Now, every layer has its own color in order to differentiate between a layer and another. And you can change the color of the layers and put any color you want. For example, you want to change this blue color into red. All you have to do is to press on the color button and choose any color you want. Then press OK, and it will be changed to your color. Now, it's very important that you choose the layer that you want to draw with before drawing anything into Rhino. For example, I want to draw 3 curves under the layer 01 at this moment. I have to make sure that I select layer 1 before I start drawing, because these lines will have the red color. They are having the red color because I selected the layer 1 color. And it's not just by lines, okay? It's not just drawing lines. You can draw any thing you want inside the viewport, and it will have the red color because it is under the layer 01. Now, if I want to shift into another layer, for example, I want to choose layer 03, this layer has the blue color. Now, if I draw something inside the viewport, the color of this box will be blue. This is because I drew this box under the blue layer. Now, what is the job of the lock? This lock locks this layer. For example, this lock is for layer 01. So if I click on this lock, this layer will be locked. So if I want to select everything inside the viewport, everything will be selected except for the objects that are drawn inside this layer. So you cannot change, you cannot adjust, you cannot rotate anything under this layer because it is locked. Once you unlock this layer, everything comes back to normal. You can move everything inside this layer, you can rotate, you can do anything you want. I just want to highlight something, that the color that is present inside the boxes has nothing to do with the color of the material of the boxes. These colors are just a reference to see which box have the same property as other objects. For example, when I see this red box and these red lines, I would definitely say that they are in the same layer, so they share some properties together. And when I see the blue color, I definitely say that this box has different properties than the other one. So this is another type than this one. Now let's go to the material options. You can put materials to any layer, and these materials only will appear on surfaces, meshes, and solids. They will not appear on curves. And these materials will not appear in the shaded category, nor the wireframe, nor the ghosted, nor the X-ray. It will only appear if you use the render option. So now, as you can see, layer 1, which has the red color, has a plaster material. And this color, this salmon color, you can change the type of the material. You can put anything you want. You can put metal. You can change the polish type of it. You can make it like shiny. Now you cannot see any salmon color because the category is shaded. Now if I flip this shaded into a rendered, you can see that everything under layer 1 has a salmon color. Let's draw anything, for example, a surface. Now you can see that the surface is white, is not salmon, because as you can see, I didn't change the layer. So that's why I told you, you have to check which layer you are working on before start drawing. So I will change to this layer and draw a surface. Now as you can see, this surface has a salmon color. I transform this surface into a mesh. The mesh also will have this salmon color. Let's delete everything and give, for example, material to this box. This box lies under the blue layer. So I want to give this box material. Let's say I want to give it the light blue color. Now you can see this layer has blue color. So everything you draw under this layer and you have the rendered section, you will see them in blue. Now let's go back to the table. As you can see, this table has one color. This means that this table is constructed under one layer. Before we drew this table, the layer that was chosen or selected was the default layer. Now this table is made up of two components. The legs, which share similar properties, so they land under the same layer, and the tabletop. So this means that this table must have two layers. Now, we go to the layer toolbar, we can see that there is a layer called legs. So I have to rename another layer to tabletop. Now I have a layer for the legs and a layer for the tabletops. Now if I select the legs and choose the legs layer, nothing will change to the legs. And the legs layer has the color green, so the legs should turn green. And this didn't happen. This is because there is some procedure that you have to do in order to transform a layer to another layer. What should you do is that you should select the layer that you want to change and then go to the layer that you want to change to this layer. For example, I want to change these legs from the default layer to the legs layer. So I select the legs, go to the legs layer, right click on the mouse and choose this one, which is change object layer. Now, as you can see, the legs have their own layer. The same thing goes for tabletop. So I would select the tabletop, go to the layer of the tabletop, right click on it and press on the change object layer. Now, since this layer has the black color, the same color won't change because everything that is black will be shown as white inside the viewport. So what I would do is that I would simply change this black for green, for example. And now you can realize that this table is made up of 2 layers. Now let's say I don't want to see the legs of the table. All I have to do is change the layer in order for me to see the light bulb of this layer and turn it off. So now there's nothing appearing under the tabletop. For now, this is everything you need to know about the layers. Let's explore other panels inside this toolbar, such as the material panel. Now, what's the difference between this panel and the material column that is present in the layer toolbar? In the layer toolbar, when you assign a material, everything inside this layer from objects, surfaces, meshes will have the same material. Let's, for example, in this layer, draw some rectangles. Now, if I shift from shaded view to rendered view, you can see that these 4 rectangles have the same material. This is because when I apply a material from the layer toolbar, this layer will affect every object inside the layer. This material panel gives you the opportunity to choose for each object a different material. This object have different material than this one, and this one have different material than the other one, and so on. So like each object is independent from the other material wise. For example, I want to change this rectangle to another color. So let's say I want to give it this light blue color. So all I have to do is to select this object, go to the material that I want to choose, right click on it and choose the first option, which is assign to object. Now, as you can see, this rectangle has changed in color. In this panel, you can add more materials by clicking on the plus. So you can choose the type of the material that you want. Let's say I want a plastic type. Then you go down to the properties and select the color for this material. Let's say I want a pink color. Now this material is added to the selection of materials. Now these materials have several properties. For example, the type plastic have several properties such as reflectivity, transparency, clarity, and bump texture. Before we try them, let us first transform this rectangle from white into the pink color. So we select this rectangle, then we right click on this color and we assign to object. Now as you can see, this rectangle had turned into a pink color. Now you can adjust the texture of this rectangle by changing the bump texture. For example, if you want it to be a leather type, now you can see that the texture of this rectangle has changed. You can change the scale of the leather, see it better. Now you can see the texture in a better way. You can also play with the transparency of this rectangle by increasing the transparency. So now you can see through this rectangle. And if you have a background, this reflectivity will play a huge role by reflecting the background on this rectangle. Now inside the material property, you can change the material of the whole layer. So in the layer toolbar, we assign this material to the whole layer. Now, if I want to change the layer, for example, from salmon to another color, I can do this step in the material panel. All you have to do is to choose one object from this layer. Let's say these objects are from the same layer. So what I would do is that I would select, for example, this rectangle. Then I go to the desired material. For example, I want to shift from salmon to this pink color. I go to this pink color, right click on the mouse and choose the second or the third option. Let's choose the second option and see what happens. What happens is that the three that were salmon in color changed into this pink. This is because I changed the layer material into the pink color. But this one didn't change because I previously changed its color. So now it's like behaving on its own. Now let's try this option by doing it by the third option. So I would choose this rectangle, go to the purple color or pink color and choose the third option. Now it will give me a list. So I would choose which layer I want to choose to change. So I want to choose the layer 1. Now I press OK and the same result as the button 2 happened. Now let's change the view from rendered into shaded. Now as you can see, we changed materials for the rectangles. We added new material, we adjusted the materials, and when we shifted from rendered into shaded, all the rectangles that were red remained red. All the boxes that were blue remained blue, and everything that is green remained green. This is because these colors are not related to the materials. They are references for the layers. Now, concerning the layers, I want to introduce at this moment a new command which will make the job of transforming from layer to another easier. This property or this command is called match properties. So you type down match properties, then you press enter. Now it's telling you to select object to modify. Let's say I want to adjust or modify the legs of the table. Then I press enter. Then it's telling me to choose a source object. So now I have to choose any object. So let's say I want to transform the legs of the table from the layer green into the layer of this box. So my source will be this box. Then I tick inside the box which property I want to have for my legs that are present inside this blue box. Let's say I just want the layer to be the same. So I undo all the rest and I keep the layer. So now as you can see, the legs of the table changed layer from the leg layer into this layer, which is blue, which is layer 3. So this is an easier way in order to transform from a layer to another. You can change more than layers. For example, if you want to, you can match the name, you can match the material, you can match the displacement, you can match anything. But this one would be the source. Now this is everything related to materials and layers. Now let's talk about the properties panel. It's present next to the material panel. This properties panel is used to give you some general information about your Rhino file. For example, in what viewport you are working on. For example, I am working inside the perspective viewport. So this is my title of the viewport. And in the projection of perspective, I could change it into parallel, into 2-point perspective, but it's the best to work with the perspective projection. Next, we have the camera angle. The camera is how you perceive the objects. Now, as you can see, when I move the cursor, the X, Y, and Z coordinates change. This is because I'm changing the camera angle. The target is when you have a precise camera angle and you want to see the objects in this target. So you type it down here. Let's say I want my target, X target to be 240 and my Y target to be 300. When I press enter, you would see that the objects have moved to my target. Now the wallpaper is the background of my objects. So the first one is that I don't have any pictures or backgrounds surrounding the object. It's just gray. So it's just the default background. So these are the properties before selecting anything inside the viewport. But let's say I want to select this rectangle. The properties will change. Now it will give me the properties of this rectangle. What is the name of this rectangle? You could name it whatever you want. And what layer is display color of this rectangle? The materials, is it a mesh? The rendering properties of this rectangle, and so on. So this is the ID if you want of the objects. So this is basically everything you need to know in this video. Thank you so much for watching this video and see you in the next one. In this video, I will be talking about coordinates. There are several types of coordinates. There is the absolute coordinate, there is the relative coordinate, and there is the polar coordinate. The reason why I am giving this lesson is because sometimes you won't be given distances in order to construct an object, but instead you will be given coordinates. So you have to draw the objects using coordinates. Now, what are absolute coordinates? Absolute coordinates are location points relative to the x, y, and z axes. So any point that has coordinates inside the grid, so it has x, y, and z values, it is an absolute coordinate. And the main thing about the absolute coordinate is that it takes point 0, 0, 0 as a reference. So let's go to Rhino and try to draw some examples using the absolute coordinates. Now in Rhino, I want you to construct a square using the following coordinates. And I want you to construct this square using polylines. So the first thing to do is to go to the polyline button and choose it. Then I want you to construct the first corner to have the coordinates of 0, 0. So you do not press anywhere inside the viewport. You just type 0, 0, and then you press enter. Now you have placed the first corner. I want the second point to have the coordinates of 0, 10. So you type down 0, 10. Now the second corner is created. And as you can see, this point is 10 points away from the first point, which is the reference. So this is why this point has absolute coordinates, because it's taking the reference of counting from the reference point. Now our third corner has the coordinates of 10, 10. Also this corner has the absolute coordinates because it is 10 points away from the reference point, which is 0, 0 by 10 horizontally, and also it's away from the reference point by 10 points vertically. Now the fourth point is 10, 0, and in order to close this square, the final point is 0, 0. So now we constructed this square using coordinates. Now I'm using the top viewport because as you saw that I used only the first two parts of the coordinates, which are the x and y. So as I'm inserting the 0, 0, the first number is responsible for the x-axis, everything related to the x-axis, and the second number is responsible for everything related to the y-axis. So since I'm only working with x and y, and the axes of the top viewport are x and y, so the best option to work in this case is in the top viewport. Now, what is the relative coordinate? Unlike the absolute coordinates, which use the point 0, 0, 0 as a reference. So let's see what's the difference between the two using this example. First, let me delete the previous example and start by constructing a polyline with these following coordinates. And the first one, I want you to use the absolute coordinate method. So the first point of the polyline is point 0, 0. The second point is 5, 10. The third point is 6, 3. And the fourth point is 10, 4. So this is the polyline that I want to construct. Now, as you can see, the second point is higher than the first one by 10 points vertically and 5 points away from the reference point horizontally. So this is because the reference is point 0, 0, 0. Now, let's construct the same polyline, the same coordinates, but with the relative coordinate method. So the first thing, I want to choose the polyline button. Then my first point, I want to give it the coordinates of 0, 0. Then in order to construct a relative coordinate, you should write down letter R before the coordinates. So my second point will be constructed at 5, 10. But since I want to construct it in the relative coordinate method, I have to write down R 5, 10. Now this is my second point. It intersects the point of the absolute coordinate method. Now, what's different between the relative coordinates and the absolute coordinate will appear right now, because this point, the 5, 10, will be the reference point for the second one. So let's construct the third coordinate, which is 6, 3. So I'm gonna start 6, 3. Now, as you can see, the third coordinate is higher than this one. It doesn't intersect the one of the absolute coordinate. This is because the last point of this line became the reference point. So the new point is away from this point, 6 points horizontally and 3 points vertically. So this last point acts as the reference point. The same will happen for the next point. The next point is 10, 4. So I will write down R 10, 4. Now, as you can see, for this point, the reference point won't be this point. The reference would be the last point constructed inside this polyline. This one would be the reference. So this final point is away from its reference point by 10 points horizontally and 4 points vertically. So basically, this is the difference between the absolute coordinates and the relative coordinates. Now, what about polar coordinates? Polar coordinates specify a point that is at distance from the reference 0, 0 and takes a direction of a certain angle. In this type of coordinates, the x-axis is taken into consideration more than the y-axis. Now let's take the same polyline that I used in the relative coordinates and the absolute coordinates as an example. So the starting point is 0, 0 of the polyline. So I type down 0, 0. Then I want my second line to have a distance of 5. Now, in order to construct a polar coordinate, you have to insert the symbol less, or it symbolizes the angle, and then you insert the angle that you want. Let's try it again. So 5, the symbol, and then I want this line to be at 50 degrees. So now I constructed this line. Now, as you can see, this line is not away from this point by 5. This is because the distance of the inclined line is 5 meters. So here in the polar coordinate, we are measuring the distance of the line and not the points. Now I will remove this short polyline and I will draw another one. So let me choose the option which is polyline. I want the first point to have 0, 0 reference. Then the second point, I want it to be a polar point having a distance of 5 and angle 50. And the third point, I want it to be at distance 6 and at 40 degrees. Now, as you can see, this line and this angle has nothing to do with 40 degrees. This is because when you draw in polar coordinates, the polyline has nothing to do with the angles. The polar coordinates are specifically for points. So what I mean is that I am placing the point at 40 degrees from the origin or the reference. So this point right here is at 40 degrees from my reference point. So if I take an angle joining this point and the reference and the x-axis and I measure it, you will see that it's 40 degrees. So when I say in the polar coordinates that I want an angle of 40 degrees, this means that I want the point to be located at 40 degrees from the reference point, which is 0, 0. Now let's say I don't want my angle to be referenced by the point 0, 0. For example, I want my 40 degrees to be starting from this point and going upwards. So what should I do? Right now, the absolute coordinate concept is being used. So everything is referenced to the 0, 0 point. Now, in order to shift to the other option, you have to use the relative coordinate concept. So let's delete everything related to this section and redraw the polyline again. So the first point is 0, 0 of the polyline. The second point has the coordinates, the polar coordinates of 5, distance 5, and angle 50. Now, in order to create an angle which is 40 degrees at this line, all I have to do is type down R before the distance or the at symbol. It's the same thing, but I prefer to use the R and the distance, which is 6, and the angle, which is 40. Now, as you can see, the direction of this section of this polyline has changed. Now you can see that the 40 degrees is taken upward. It's not like the one before, which is like a line right here. This is because the reference at this moment is the last point of the polyline. So it takes 40 degrees from this point. So if we measure this angle right here, this angle would be the 40-degree angle. So this is the difference between the polar coordinates and the absolute coordinate fused together and the polar coordinates and the relative coordinates fused together. So basically this is everything related to coordinates as tutorial. Thank you for watching, and please don't forget to watch the next video targeting the exercises of the coordinate. In this video, you will be applying the coordinates lesson in an exercise. The exercise is about an arrow. You have to construct this arrow that has distances, coordinates, and angles. You have to construct this arrow using the absolute, the relative, and the polar coordinates. And I want the measuring unit to be in meters. So let's start by creating this exercise. First of all, we should launch the Rhino application. Then I should start a new file and choose the measurement to be meters. So I have this one for small objects meter. Since this arrow is small, so I think I should choose the small object meter. Once the Rhino file opens, I should rename this file into exercise or coordinates. Now I check if this title is written properly. So in the window title, so exercise 4 coordinates. And now I will start. Since the arrow is just in 2D and I will be only working with X and Y axes, I prefer to work in the top viewport. So I will enlarge this viewport in order to see better. Now the first thing I do is start by looking at a reference point. So the first thing that I could see in this arrow, this point which is 0, 0. So I choose the polyline option and I type down 0, 0 as a starting point. Then I look for the easier option in order to start this application, or in order to construct this arrow. As you can see, this point is the easiest point to start with, because this point I don't have any information about it. So now I have the second point that has the coordinates of -2 and 3. And since I am starting from the origin, so it is an absolute coordinate, -2, 3. So now I created the second point with respect to the reference. Let's see what's next. The third point is away from the second point by 11 meters. Now let's go back to the basics of Rhino. Each square inside this grid is a unit. So the distance between one point and another inside this grid is 1 unit. In this case, it is 1 meter. So based on this information, the third point is away from the second point by 11 points with respect to the x-axis. So now we know the first coordinate of the third point, which is equal to 11. Then the second part of the coordinate, you should choose which one you want. You want to work with absolute coordinate, or you want to work with relative coordinate. Let's start by constructing this point using the absolute coordinate. So in the absolute coordinate, you know that you want to calculate the y-axis based on the origin 0, 0. So since this point, the previous point, has a y-axis of 3, and this point is on the same height of the previous one, so this point has a y-axis coordinate of 3. So now I constructed this third point using the absolute coordinate method. Now if I want to construct this point using the relative coordinate, this means that this point, which is -2, 3, is my reference point. The x-axis of the third point is away from this one by 11. So I type down R, 11. Then the y-axis, as we can see, that it is at the reference point. And since the reference point is equal to 0, I have to type down 0. It's not 3 anymore because I'm not taking the 0, 0 as a reference. I'm taking the -2, 3 point as a reference. And this is how I create the third point using the relative coordinate method. You can also construct this point using the polar coordinate by setting a point which is 11. Let's say R11. And at an angle of 0 degrees because I don't have any inclination. So this is how I created this point using the 3 coordinate methods. Now let's construct the fourth point. The fourth point is away from the third point by 2 meters. And this point is located at an inclination of the third point. In order to construct an inclination using coordinates, you should use the polar coordinate method. Now, the polar coordinates need a distance line and an angle. In this given, you have this angle, which is 50 degrees. But this angle cannot be used in order to construct a polar coordinate because we need the angle between the x-axis and the distance line. In order to calculate this angle, we should subtract 50 degrees from the 90-degree angle that is forming here. So this will leave 40 degrees for the angle of the polar coordinate. Now we have the coordinates of the polar point. So let's construct it. We choose the polyline option. We choose the starting point to be the third point. And then we type down 2 for the distance of the line. And then we put the angle symbol and we type down 40. Now, as you can see, the angle is not the desired angle that we want it to be. This is because this way of writing leads to the construction of a polar coordinate having absolute coordinate method. So in order to have the desired angle in this arrow, you should use the relative coordinate method. So what we have to do is to write R behind the 2, and now you can see that the reference point has changed and became the third point. Now the angle is shifted upwards. In order to shift down the angle, you should type down minus 40 degrees. So now the quadrant has changed. And since this is the shape that we want, we press enter. Now the next point is 10 meters away from this point. So in order to construct this point, we can use the same method that we used at first while constructing the third point. So since we don't know the coordinates of the fourth point, it is better to use the relative coordinate point system. So we type down R10, since we know that the horizontal distance is 10 meters, and then we put comma, and then since this one became the reference point, so the coordinates of this point is 0, 0, so the y-axis has to be 0 in order to have a horizontal line. So we type down 0. So now we constructed this horizontal 10-meter line. You can construct this line using the polar coordinate system by choosing the first point to have a distance of 10 meters. And since we have to choose an angle, so this angle, if this is the reference point, which is 0, 0, and we want the point to be at the same height of this point, so the angle is 0 degrees. Down the angle symbol and you type down 0. So we created this line using two methods. Now, if you want to know the coordinates of this point, all you have to do is choose the line that has this point and press on it. Now you can see in the status bar the x and the y of this point. So this point has x, which is 10.48, and y 1.72. This is how you know the coordinates of points. So now since we know the coordinates of points, you can construct this point using the absolute coordinate method. So now let's see what's next. The next point that I will be creating is 1 meters above the previous point. And since we don't know the coordinates of this point, we should use either the polar coordinates or the relative coordinates. So first, you should choose the polyline button, choose the starting point, which is the last point that we created, and then start typing the coordinates. Now, since this line is directed vertically, so the value of the x-axis coordinate is 0. So you type down R, 0, comma, and since the distance of this line is 1, so you type down 1. So this point is created. Let's see the other point. The other point has the coordinates of 25, 0. So this point is referenced by the point 0, 0. To construct this point, we can use the absolute coordinate method. So we just type down 25, 0. Now let's see the next point. The next point is located at coordinates 20.4 and minus 2.76. So these coordinates are also referenced by the point 0, 0. So the easiest thing is to choose the absolute coordinate method to draw this point. Type down 20.4, minus 2.76. And this point is created using absolute coordinate method. Now the next point is 1 meters above this point, which is the 20.4 and minus 2.76 as y-axis value. So in order to construct this point, you can do it in the three ways. In the absolute coordinate method, since we have the coordinates of this point, the relative coordinate method, and the polar coordinate method. Now let's try the absolute coordinate method to construct this point. So this point had the x value to be 20.4. And since this line is vertically placed, so the x value is still the same. So you type down 20.4. Now, since this point is higher than the previous point by 1, so the new point should have the coordinate, the y coordinate, minus 1.76. So in this method, I created the new point. Now, if I want to create this point using the polar coordinate method, I know the distance of this line, which is 1, but I don't type directly 1 because I want this point to be my reference point. So I type down R1, I type down the angle symbol, and then since this line is vertically placed, the angle of this point is 90. And I created this point in another method. Now let's see the other points. The other point is away from the recent one that I made by 10. So I can use the coordinates to construct the new one, or I can use the relative coordinate method to construct it. I think it's easier to use the relative coordinate method to construct it. So I just type down R, and since this one is my new reference point, which is 0, 0, and I'm going to the left side, I should type down minus 10. Then I paste comma, and then this line is horizontal line. So I don't have any value for the y-axis. So I type down 0. So this is my new point. The next point is the same as the upper part point. So it's inclined by 2 meters, and I have the inner angle, which is 50 degrees. So in order to calculate this angle, I should subtract 90 and this angle. So the remaining angle is 40 degrees. So what I have to do is to apply the polar coordinate system. So I type down R because I want this last point to be my reference point. I type down 2, then I put the angle symbol, and I type down 40. Now, as you can see, the angle is not in the desired position, so I type down minus 40. Also, this one is not applicable. So what should I do is that I should recalculate my angle. So since this one is my reference, and this is my x-axis, so I should add 40 to the 90 in order to have this bigger angle, which I want. So now I could see that my angle is 130. But this angle is 130 upwards. In order to flip the angle, I should type down minus 130. And now I have the desired shape and the right angle. So I press enter. Now let's continue the last part of the arrow. The new point that I will be creating is 12 meters away from the last point that I created. So let me choose the polyline button, choose the starting point, which is the last point present inside the viewport, and then choose the options. You can choose one of the 3 options, but since we don't have the coordinates of this point, it is better to choose the relative coordinate method or the polar coordinate method. Now, if I want to construct it in the relative coordinate method, I do the same thing that I did in the previous parts. So I type down r, then I type down the distance of this line, which is 12, comma, since this line is horizontal, so any vertical coordinate is 0. So there is no value for the y-axis, So now you can see that this line is shifted in the other direction. So all you have to do is to type down -12, and the line will be directed in the way that you want. Now, if we want to create this line in the polar coordinate method, you choose the polyline button, you choose the starting point to be this reference point, you type down r, and the distance of this line, which is 12, and then you choose the angle to be 0 degrees because we are working in a horizontal direction. And the same thing is that you have to put a negative value for the x-axis. So this is how I created this point. And the last point is relating everything together and going back to the 0, 0 reference. So all you have to do is type down 0, 0 and press enter. And this is how you construct an arrow or any figure using coordinates. Thank you so much for watching this video, and see you in other exercises. In this video, you will learn about adjusting and modifying lines. And in this video, I will be talking about rotation, trimming, and scaling. Let's start with the rotation. What is rotation? Rotation is when an object flips around the world axis into a different position, or this object shifts into different angles in the same plane. Here are some examples of rotation. For example, the first one, you have this rectangle which is placed in this direction. This rectangle will be flipped around the x-axis in order to become in this shape. Another example is for this rectangle, which will rotate around the z-axis in order to have this form. The third example is when we have a rectangle which is placed in a certain position and it rotates in place in order to have a different angle. So these are examples of rotating an object. Now let's try the rotation process inside Rhino. I opened a new Rhino file, and since we are practicing modifying and adjusting lines, I will be drawing some rectangles of different sizes, some circles, some ellipses, and some lines in order to practice the rotation procedure. Let's say I want to choose this rectangle to start the rotation process. In the introduction, I said that there are two types of rotation. Either rotation around the axis, like this one, or rotation in place at a different angle. Now inside Rhino, there are two ways or two methods for rotation. Either you can use the gumball, which is present here, or you type down rotate and you start applying the rotation on the object. Now let's start by using the gumball method. Each viewport has some curve responsible for the rotation inside this viewport. For example, in the top viewport, you can see that the axis of this object is x and y. So the curve responsible for the rotation inside the x and y axes, or between the x and the y axes, is the blue curve. In the front viewport, where the x-axis and the z-axis are present, the green curve is responsible for the rotation. In the right viewport, you can see that the color of the curve is red. So the red curve is responsible for the rotation between the y-axis and the z-axis. And in the perspective viewport, you can see that the three curves are present. So you can control any direction you want to rotate inside the perspective viewport. Now let's say I want to rotate this rectangle inside the top viewport. So all you have to do is to left click on this curve and slide the rectangle in the direction that you want to rotate. Now, as you can see in the perspective viewport, this rectangle is rotating between the x-axis and the y-axis. Now you can rotate manually to whatever point you want, or you can left click on this curve and choose a certain angle in order to rotate. Let's say I want to rotate this rectangle 20. So this rectangle is rotated 20 degrees from the x-axis. So this is option 1 for rotation. And I tried the rotation in the XY plane. Now let's try this same option but using the command rotate. You type down rotate in the command prompt and you press enter. You select the rectangle or the form that you want to rotate. Then you choose a center for the rotation. You can choose any corner of this rectangle. Let's say I want to choose this one. And then you choose an angle as a reference for this rotation. I prefer to choose a straight angle, so I will go for the other point in order to have a 0 degree. And then as you can see, there is an angle reference appearing in the viewport. This will determine how much this rectangle will be rotated. So you can place it manually, or you can type down the angle that you want this rectangle to be shifted to. Let's say I want this rectangle to be shifted 30 degrees, and I press enter, and my rectangle is shifted upwards 30 degrees from the x-axis, which is a straight imaginary line. Now, let's rotate this same rectangle in a different viewport. Let's say I want to rotate it inside the front viewport. This rectangle is perceived as a straight line inside the front viewport. And the difference between the top viewport and the front viewport are the axes. So this rectangle has an x-axis and a z-axis in the front viewport, while in the top viewport it has the x and y axes. Now, since it has the x and the z, this curve represents the y-axis, the missing one. So we can say that this rectangle will be rotating around the missing axis, which is the y-axis. So let's rotate this one using the gumball. It is the same procedure that we did in the top viewport. So we press on the left click of the mouse and we drag this gumball to the different positions or different angles that we want. Now, as you can see in the top viewport, this rectangle is rotating around the y-axis. And you can see this rotation in the 4 viewports. And the same thing applies for this viewport. You can left click on this curve and choose the angle of rotation that you want. It could be a negative value or it could be a positive value. And this rotation will be relative to the y-axis, not to the x-axis. So this one would be shifted 20 degrees from the y-axis. So this is the difference between the top viewport and the front viewport. Now let's go to the right viewport. You can see that this object has the y-axis and the z-axis. So this rectangle will be rotating around the missing axis, which is the x-axis. And this curve, this blue curve, represents the x-axis. So let's do the same procedure. We left click on the mouse, we keep on pressing and dragging. Now you can see this rectangle is shifting direction around the x-axis. And the same thing applies here. You can just left click on this curve and choose the angle that you want. And this angle would be also like the top view one relative to the x-axis. So this is what is common between the right viewport and the top viewport. Now in the perspective viewport, you can choose any curve or any axis and rotate around it. So this is why I prefer to choose the perspective viewport in order to rotate, because I can see the three axes all together at once and I choose whatever curve I want. Now let's say you don't want to use the gumball. You want to use the command of the rotation. What should you do? The first thing to do is to type down rotate command. Then you press enter. Then Rhino asks you to select the objects that you want to rotate. Let's say I want to rotate this same rectangle. Then you have to choose a viewport in order to rotate in. Let's say you want to rotate in the front viewport. You choose a center of rotation inside this viewport. Let's say this point. Then you have to choose an angle for rotation. But you have to remember that inside the front viewport, the rotation is around the y-axis. So any angle you take now will make this object rotate around the y-axis. So let's say I want to take a reference point for the rotation, this point. So this point would be the point 0, 0. Now you can see that there is an angle, an imaginary angle appearing, and this will indicate the angle that I'm rotating this rectangle. So let's say I want to choose an angle of 50 degrees. This rectangle is rotated 50 degrees from the y-axis. Same thing applies for the other viewports. Let's say I want to rotate this rectangle, this same rectangle inside the right viewport. So I make sure that the right viewport is chosen. Then I choose a center for my rotation, an angle for my rotation, and I choose how much I want to rotate it. But this method can be a little bit confusing because sometimes the angle that you choose are misleading. So I prefer to work in the gumball method. Now I tried the rotation in this rectangle. Let's try, for example, rotating a circle or an ellipse. The same application that we did to the rectangle applies to any line or any form of 2D line. Ellipse, circle, polyline, anything. The same procedure is taken into consideration at any shape. So let's say I want to rotate this ellipse or between the x and the y axis. So this ellipse will be rotating around the z-axis since the z-axis is absent. So this curve is representing the z-axis. So now you can see the rotation and the different viewports. And as you can notice that in the front viewport and the right viewport, the object is rotating in place. Let's rotate it in different viewports. You can see that it is shifting directions and it is rotating around a specific axis. Let's try the rotation with the polyline. The same thing applies here. Now, if you want to rotate, for example, this polyline in angles which are right angles like 0 degree, 90 degree, 180 degree, all you have to do is either switch this ortho on or press shift. So now you can see that this polyline or this line or any curve is rotating in a 90 degree angle. So let's say I want to rotate this one in a 90 degree. So I turn on the ortho, or if it is off, I keep on pressing the shift while rotating. So this is basically everything related to rotation. And let's see what is trimming. What is trimming, or what is a trim? A trim is an easy, straightforward command used to remove part of an object using another cutting object. For example, in this illustration, we have a segment which is very long, and we applied trimming to this segment. As a result, you can see that this segment was shortened because we used a cutting object to cut this segment into two parts, and the unwanted part was deleted. Now, let's try the trimming process inside Rhino. In order to apply this trimming inside the Rhino, you should create a cutting object, or you should create at least an intersection point or two with the object that you want to trim. Let's enlarge the top viewport and work inside this viewport. For example, I want to trim this ellipse. I don't want the lower part of the ellipse. All I have to do is to create an intersection point with this ellipse. You can intersect anything with this ellipse. Let's say I want my cutting object to be a polyline. You go to the polyline, you choose the polyline button, and then you create a polyline which is intersecting with this ellipse at 2 points. Now, the second thing you have to do is to type the trim command in the command prompt and then press enter and see what Rhino tells you to do next. The next step is to select the cutting object. Everything that is intersecting the object that we want to cut is a cutting object. So it could be a surface, a cube, a line, a curve, anything that intersects the object that I want to cut is called a cutting object. So in this case, the cutting object of the ellipse is the polyline. So I select the polyline. Then I press enter. Now I have to choose which part I want to delete from this ellipse. Let's say I want to delete the upper part. All I have to do is to select this upper part, and as a result, the selected part would be deleted. So now you can see that only the bottom part of the ellipse is present. Now, if I want the bottom part to be deleted, let's type the command again. I have to choose the bottom part to be deleted, leaving the big part of the ellipse present in the viewport. Now let's say I want to cut this polyline. So I just want the part that is intersecting the ellipse to still be present inside the viewport. I don't want this part to be present, and I don't want this part to be present. So now things changed. Now this line has become the object, and this ellipse has become the cutting object. I type down trim, I select the cutting object. So basically this half ellipse is now my cutting object. I press enter, and then I want to select the unwanted parts. So this is the first part that I don't want, and this is the second part that I don't want. Once I finish deleting everything and having the desired part that I want to be present in the viewport, I press on the enter. So now you can see that you can have the cutting object become the object and the object become the cutting object, depending on the situation and depending on which part you want to delete. Now let's apply this trimming command to other objects. For example, let's trim this polyline. So we have the object, now we have to create a cutting object for this polyline. So let's, for example, choose a surface to be the cutting object. So we draw a surface that is intersecting with this polyline. So this surface is intersecting this polyline at this point and at this point. So now you type down trim, you select the cutting object, which is this surface, and then you choose the part that you want to delete from this polyline. You can choose either this top part, you can choose the middle part, which is between the surface, or you can choose the bottom part. It's up to you which part you want to delete. Let's say I want to trim this line which is between the surface. All I have to do is to select it and it would be deleted. So now this polyline is divided into two curves or two polylines. Let's say I want to trim the top part. So I type down trim, select the cutting object, which is the surface, and then I trim the top part, and then I press enter. Now you can see that this is the remaining part of the polyline. Now if I want to trim this surface, so my cutting object is the polyline. So I type down trim, select the cutting object, which is the polyline, and then I choose the part of the surface that I wanted to be deleted. And now, as you can see, this surface is shortened. Now let's try to cut this rectangle. If you want to trim this rectangle, a cutting object should be present. And since this polyline is intersecting this rectangle at this point, so this would be the cutting object. Now logically speaking, since this cutting object is intersecting this part of the rectangle, so either this part of this side would be trimmed or the larger side of this part would be trimmed. So let's try to trim the smaller part of this side. So you type down trim, then you choose the cutting object, and then you select the part that you want to trim. Now as you can see, the whole rectangle got deleted. There are two explanations for this to happen. The first explanation is that in an object that has more than two sides, the cutting object should intersect this object by 2 points. So you cannot trim a square or a rectangle by just 1 point. So if we draw a line having 2 intersection points with this rectangle and we type down trim, you can see that this rectangle was trimmed by this side. The second explanation is that a polyline cannot cut this rectangle. Only a single line can cut this rectangle. So let's construct one single line intersecting this rectangle and see if this can work. So we type down trim, we select the cutting object, and then we choose this small part, for example. Now you can see that the small corner of this rectangle has disappeared. And not just this small part of the side of the rectangle disappeared. This is because when you create a single line, an imaginary intersection tends to be created. So in fact, when you draw this single line, you are drawing another intersection with this square on the same level of this line. So as if you extended this line to reach a point on the other side of this rectangle. And this is why this whole corner of the rectangle was trimmed. So let's try this one again. As you can see, it trimmed this corner. And if we extend this line, you can see that this is a straight line. So this is like an imaginary extension of the cutting object. So this is basically everything related to trimming. Let's move on to the scaling command. What is scaling? Scaling is when you change the proportion of the measurements of an object in order to make this object look smaller or bigger. In this figure below, you can see that this is the same object. It has the same characteristics in the 3 states, but it has different scales. Now let's go to Rhino to understand the scale command more. First, let me delete everything inside the viewport, and I will draw a new rectangle. Let's say I want to create a rectangle with dimensions of 10 meters by 5. Let me zoom it a little bit. So now this is my rectangle. Now if I want to apply the scale command, I should type in the command prompt scale. Then Rhino asks me to select the objects that I want to scale. So I would select this rectangle. Then it asks me to select a base point. A base point is a reference point, so you can choose any point. I prefer to choose a side of a rectangle. Then it is asking me to choose a scale factor or the first reference point. But what is the scale factor? The scale factor is a number that is responsible for enlarging the object or making the object smaller. So for example, if I want to write down a scale factor of 2, this means that the length of this rectangle would be multiplied by 2. For example, this length of this rectangle is 10 meters. So now if I type down scale factor of 2, the side of this rectangle will be multiplied by 2. So the length of this side will be 20 meters and the side of the other side would be 10 meters. Let's try it. So now as you can see, this rectangle got bigger, and in order to make sure of the measurements, the length became 20 meters and the width became 10 meters. Now let's say I want to do the scaling factor to this rectangle, but I want to make it smaller. So let me redo this command and choose a scale factor of 0.5. This means that the length and width of this rectangle will be multiplied by 0.5. So now if I type down 0.5, this rectangle would be smaller and the sides of the rectangle would be decreased by half. So you can put any scale factor that you want, but you have to calculate it before in order for this rectangle or this shape to be accurate. Now if you want to use the reference point, you do the same thing. You choose a base point, then you choose the first reference point that you want to scale from. Let's say I want to choose this reference point. And then as you can see, this rectangle is getting smaller or bigger depending on where I put my second reference point. If I put my reference point, my second reference point here, this rectangle would be smaller. If I put my reference point outside the first reference point, the rectangle would be bigger. So this is how you scale with the reference points. Now the scaling technique cannot be done using the gumball. The scaling technique cannot be done using the gumball button because when you drag the gumball button, you are changing the distance or the length of two sides of the rectangle. You are not changing the proportion of the whole rectangle. So for example, if you drag this point, you are changing the length of the rectangle, but the width is the same. The same thing is happening if you change the width of the rectangle. As you can see, the proportion of the rectangle is not changing. You are just changing the dimensions of the length and the width. So this wouldn't be the definition of scaling. So basically, this is everything related to the scaling and the scale factor. Thank you so much for watching this video and see you in the next videos. In this video, I will be talking about some features used for lines, such as join, extend, split, and fillet. Let's start with the join command. Join is used in order to convert two lines that are attached to each other and make them one curve. So at this moment, you can see in the viewport that I drew two lines. In order to make these two lines one curve or one polyline, all you have to do is to select these two lines and type inside the command prompt join. And then if you reselect this line, both lines will be selected. This is because they are converted from two lines into one line or one curve. Now the join command doesn't work if the lines are not attached to each other. So these lines are attached to each other, so I can join them. But if the lines are not attaching each other, let's say I have a line here and a line here, and you try to join them, you can see that unable to join curves is written in the command window. Now the same thing applies if you want to draw more than two lines. Let's say I want to draw this line, 2, 3, and 4. And I want to join these 4 lines in order to become one closed curve. So I select all the lines that I want them to be joined together and I type down join. So now you can see in the command window that 4 curves join into one closed curve. So this is how I created a closed curve using the join command. Now let's say I want to construct a polyline. And by mistake I ended this command, but the design is not finished. So I want to continue this design using another polyline. Let's say this is my final shape, and I want to join this part with this part. So what should I do? I select both parts and I type join. And as you can see, this is converted into one curve. So the join command is applicable if you want to join 2 single lines, or if you want to join a polyline and a single line, or if you want to join 2 polylines together in order to form one curve or one polyline. Let's try to join one single line and a circle, for example. But I want to attach this circle to the end of the line. I select both of them and I type join. Now as you can see, Rhino is telling me to select an open curve to join. And since the circle is a closed curve, or any shape such as the rectangles, the ellipse, the polygons, all of them are closed curves, I cannot select them. So the join command is not applicable in this case. You cannot join an open curve and a closed curve together. You can join 2 open curves, you can join 3 open curves, you can join 4 open curves in order to form a closed curve, but you cannot join a closed curve and an open curve. So this is basically everything related to the join command inside the line section. Let's move on to the extend command. Now let's say I want to create a horizontal line and a vertical line. They are not intersecting, but I want them to be intersecting. And I don't want to add any extra extensions such as this line. What should I do? The right answer is to apply the extend command. So you type down in the command prompt extend, you press enter. Then the first thing to do is to select the line that you want the other line to be extended to. For example, I need to select this line because I want the other line to be extended to this line. Once I select the first line, I press enter. Then I select the curve to extend. So I want to select this curve in order to be extended to the other one. So I just select it. And now you can see that an extension is created. Now let's say I want to create this line and I want it to be extended to this circle. So the first thing to do is to type down extend, then select the first boundary object, which is the circle, because I want to extend the line to the circle. So the main source of extension is the circle. Then I press enter, then I select this line. So that's how I extended my line in order to intersect the circle. Now you can extend this line to the other side of the circle by also typing extend and choosing the circle for another time, and then choosing this line for another time. Now, as you can see, this line is extended into the other intersection point of this circle. The same thing goes for the rectangle, for example. Let's try it. I'm drawing this line, and I want, for example, this line to be extended to this extremity, to the farthest extremity of this square. So in order to do this, I type extend, choose the source, which is the square, and then I have to choose the curve in order to extend. The first selection extended the line into the first part of the square. Now, if I selected this line for a second time, this line will be extended to the other extremity or to the other side of the square. Now, if I select it a third time, as you can see, nothing will happen. It will give me the last intersection point between this line and this square. So basically, this is everything related to the extend. Before I finish everything related to the extension, these extensions only are applicable for the open lines. You cannot extend curves using the closed curves, such as extending, for example, the extremities of this square into this circle. So you cannot, for example, extend this side of the square into this circle. Now everything is ended concerning the extend command. Now let's talk about the split command. I talked about the trimming command, where you have an object which is being cut by a cutting object, and you choose the part that you want to delete. The split command has the same concept. It has an object and a cutting object, but it doesn't delete anything. Let's try the split command in order to understand it better. Let's say I have this line, and I have, for example, a cutting object, let's say another line. Now what I have to do is to type down split. Then I press enter. I have to choose at first the object that I want to split. Let's say the horizontal line. I press enter. Then I have to choose the cutting object. My cutting object is the horizontal line. Then I press enter. And now, as you can see in the command window, it is telling me that one curve split into two pieces. So I have this one piece and I have this other piece. So the cutting object inside the split command is just splitting this object into different pieces. Let's say, for example, my cutting object is a surface. Let me type down split. Choose the object that I want to split. Let's say I want to split this line. And my cutting object, now before doing this, let me use the other command, which is the join command, to join these lines together. And then restart by doing the split command. So my object that I want to split is this line. Then my cutting object is this surface. Now you can see that inside the command window, it is telling me that one curve split into three pieces. This is the first piece, which is from this side. The second piece is inside the surface. And the third piece is the one at the side. So as you can see, the cutting objects only is cutting my object. It's not deleting anything. So this is everything related to the split command. Now let's try the fillet command. The fillet command is used in order to join two lines that are away from each other. So let's draw a set of lines that are away from each other. So this is line 1 and this is line 2. As you can see, these lines are away from each other, or they are not attached to each other. but I want to attach them. So all I have to do is to type down fillet and choose the first curve, then choose the second curve. Now, as you can see, these two lines are attached using joint curve, and this is how they are attached to each other. But they are still separated segments. They are not joined into one curve. Now you can fix this thing by adjusting the options of the fillet. So let us draw another set of lines and adjust the options of the fillet. Let's say I have line 3 and line 4. I type down fillet. Now before choosing the first curve, there are some options here. You can adjust the radius of the connection of these two lines, the joint. So you can make this radius bigger, you can make this radius smaller. Let me choose a value, for example, of 6. Then the second option is join. If you want these segments to be joined together into one curve, you change this into yes. Now, if you want this joint to be, for example, not arc, a line, you change this option to line. Or for example, you want an edge which is not curvy, all you have to do is to change the radius into 0. There are two options to change the edge of this connection. So let's say I finished adjusting the settings of the fillet. Now it's time to choose the first curve, which is curve 3. And curve 4 or line 4 is my second curve. Now, as you can see, this circle or this joint has become bigger because I made the radius become 6. It was 5 in this case. And now if I selected this line, you can see that it is all attached to each other because I chose the option to be join yes. So this is how you join two lines that are not attached to each other. So this is basically the fillet command. This fillet command is only used in open curves. It cannot be used in closed curves such as circles, squares, ellipses, or anything that is closed. Thank you so much for watching this video, and don't forget to watch the other videos explaining other features of the lines. In this video, I will be continuing the features related to lines, and I will talk about group, mirror, and offset. Let's start with the group. What is grouping or the group command? Let me start by constructing some rectangles of different layers inside the viewport. Let's say I want to construct this rectangle away from the one above and one up here. Let me enlarge the top viewport in order to see the rectangles better. So I have these types of rectangles having different colors, so representing different layers inside the viewport. I want to rotate these rectangles 90 degrees, but I don't want to rotate each one alone. So I don't want to select, for example, this rectangle and rotate it by itself 90 degrees. I want to do this job once and for all. So the best way to do this option is by applying the group command. The group command groups objects of same or different layers under the same basket in order to perform a certain command for all of them. What should I do is that I should select all these rectangles and type down group. Then I press enter. Now what's happening is that if I select one rectangle, all the rectangles would be selected. But if you noticed that the layers are still the same as before, so the grouping didn't affect the layering of these rectangles. So each rectangle will keep on having the same layer and nothing will be changed. But this will make our job easier because now if you select, for example, this one, everything will be selected under this group, so you can rotate this rectangle all at once in a certain direction. You can move these objects at the same time. You can scale these objects. So every command you apply will be applied to all of them. So this will make the job easier. Now let's say you don't want to group them anymore. All you have to do is to select them and type ungroup. Now each rectangle will return alone and by itself. So now these rectangles are not attached to each other anymore. So this is everything related to grouping. Now let's move on to the mirror command. Let me first delete everything inside the viewport and have a close-up on the grid. In the previous videos, we did an exercise of an arrow. And the first thing we did that we drew half of the arrow. And then we drew the other half by having some coordinates. Now let's say, for example, I have this figure. This figure is symmetrical on the other side, but I drew half of it. There are three options in order to continue this figure or this object. You can either have the coordinates or the length of the remaining part of the image, and you can use them to construct it. The second way is to copy this part and go to the perspective viewport, shift or rotate the angles in order to have a symmetrical shape, and then you move these parts together. So now you can see that I created this symmetrical object. Now the third way to create this symmetrical object is by using the mirror command. Let me delete this part. In order to apply the mirror command, you should select the part that you want to mirror. Then you type down mirror. Rhino is telling me to start the mirror plane. So I have to choose a point to start the mirror command. Let me choose this point. Now I have to choose an endpoint for this mirror option. So if I want my command to be mirrored horizontally, I choose this point. If I want my mirror to be vertically placed, I press on this point. So it depends on the direction that I want. So let's say I want it to be symmetrical horizontally. So all I have to do is to press this point. And now you can see that my image is complete and it is symmetrical. You can also do this mirror command without choosing a starting point or an end point. So let me redo this command again. You have to select the object to mirror. And then you have to choose some of the options before starting the point of the mirror plane. Let's say you want to mirror this object horizontally. Instead of putting a starting point and an end point, you just pressed on the x-axis. And Rhino will do the job for you. You can see now this half part is mirrored horizontally on the x-axis. Now let's say if you want to mirror this same object vertically, all you have to do is to press on the y-axis. And now you can see that this object was mirrored with respect to the y-axis. So the mirror command facilitates a lot of work for you. So if you have any symmetrical shape, it is enough to draw half the object and then mirror the second part of the object. So this is everything related to the mirror command. Let's see what is the offset. Now, what is offset? Offset is an easy and straightforward command, and it is used in order to create a duplicate or a copy of a line or polyline at a certain distance of the original line or polyline. For example, let's say this is my original polyline. I want to create a copy of this polyline having the same shape at the distance of this polyline by 2 meters. I want it to have the same shape. But I want a different proportion of this line. So the best thing is to apply the offset command. So you select the original polyline and then you type offset. Now you select the original polyline or line that you want and you choose the distance that you want to offset. Let's say I want to offset 2 meters. I type down 2 and I press enter. Now you can see that the distance between my original line and my copy line is 2 meters. Now I have to decide whether I want my copy line to be above the original line or below the original line. Let's say I want it to be below the original line. So I left click on the mouse when it becomes at the bottom. So now as you can see, this is the original line and this is the offset line. It has the same shape as the original line, but it has a distance of 2 meters away from the original line. Now there are several options for the offset. You can control the corners of the offset, you can control the distance, you can control, let's see what we can control. Let's type down offset again. Choose the curve. This is the original curve. You can change the distance. You can change the type of corner. Right now it is sharp. As you can see, it is a 90-degree corner. You can change it to be round. You can change it to be smooth. The smooth command is a round command, but it has a smoother surface. You can change also the option to chamfer. So now you can see that the corners are chamfered. You can choose the offset on both sides. So it will shift in this position and in this position if you want the both sides. So you can choose any option you want if you want to adjust the offset command. This is everything related to the offset. Thank you so much for watching this video, which I talked about the offset, I talked about the group, and I talked about the mirror. Don't forget to watch other videos which I will talk about more features of the lines. In this video, I will be talking about array and chamfer. And these are two features used for lines. Let's start with the array. What is an array? An array is when you create copies of a line or a polyline in a certain sequence. There are several types of array. You have the polar array, you have the planar array, and you have the directional array. Now, what's the difference between the three? The first one, which is the polar array, makes copies of an object in a circular form around this object. So let's say this object is the circle in red. So as you can see, the copies are around this red circle and in a circular shape. While in the planar array, this circle has copies in the X, Y, and Z directions. So it creates copies in the planes around this object, while the directional array picks up a path and create copies corresponding to this path. Now let's do some example of arrays inside Rhino. I opened a new Rhino file and I will explore the array commands. The first thing to do is that I should create a curve inside the viewport. It could be any shape, a circle, a rectangle, a polyline, a curve, anything. Let's create, for example, a rectangle. Then I will choose the perspective viewport for this exercise. The third thing to do is to choose whether you want to start with polar array, planar array, or a directional array. Let's start with the polar array. In order to apply the polar array, you should type down array polar. Now Rhino is telling you to select the object you want to array. So I will select this rectangle. Then you have to choose a center for this polar array. Since the polar array creates copies in a circular way, so you have to choose the center of this imaginary circle. So let's say I want to choose this point. Then you have to choose the number of copies you want this array to copy the original object. For example, you want to copy this object 5 copies. You should type down here 6 because Rhino makes 5 copies and count the original one as another copy. So for example, if you want to create 4 copies of this object, you have to type down 5. The next step is to choose the angle of the polar array. You could choose reference points, reference 1, reference 2, or you can type down the angle that you want this polar array to have. Let's say I want to type down 45 degrees. Then in order to confirm this shape, you press enter again. As you can see, the polar array is created. So there is 4 copies shifted in a 45-degree position, and all of them have the same center that I selected for the polar array. Now let's do the same thing but choose a different center for the array. So I type down array polar. I choose the object. So let me choose the same original object like I did before, and then choose a center outside this rectangle. Let us choose, for example, a center here. And I will keep the same number of items as before, which is 5. Then I will choose an angle. Let's say I'll keep it 45. Now you can see that the position of the array has changed because we changed the center of the array. So you have to pay attention where you have to put the center of the array in order to have the right outcome. Now there are other options inside the array button. So let me make a copy of this rectangle in order to do another example. So let us do the same steps that we did here on this rectangle. So I would type down array polar. I choose my object, which is this one, and then I choose a center. But now instead of choosing an angle or a reference point for this polar array, I would change the options that are present here. So the reason why these rectangles are seen in a circular form is that because the rotate option is set to be yes. But if I shift this one to be no, what will happen is that when I choose an angle, you can see that this rectangle is radiating in this direction. It's not shifting 45 degrees. This is because we are not letting it to rotate. We shifted the rotate option into no. So it's taking the radius 45 degrees from this point and like making offsets of this original object. So this is the difference between having the rotate button on and the rotate button off. Now let's try the other type of the array, which is the planar array. Now let's create a new rectangle in order to perform this command on. Let's say this is my rectangle. In order to apply the planar array command, you should type array and nothing but array. Then you press enter. The next step is to choose the object you want to array. Let's say I want to array this square or rectangle. Then I have to choose how many copies I want this rectangle to have in the x-axis. Let's say I want this rectangle to be copied 3 times. Now I have to specify the number of copies in the y direction. Let's say 2. And the number of copies in the z-axis or z direction is also 2. You can choose any values. I'm just typing numbers. Now the next step is to specify the spacing between those copies. You can type down values or you can set the spacing manually. Let's try one of the 2 options. Let's try, for example, setting a value. Let's say I want the spacing between the copies in the x-axis to be 20. Also, I want the spacing between the copies inside the y-axis to be 20. And same goes for the copies in the z-axis. Now, in order to confirm this command, I should press on the enter. Now you can see that this rectangle or square is being arrayed or plain arrayed. So we inserted the value of 2 in the x-axis. We inserted the value of 3 in the x-axis. So we have 2 other copies than the original one. Now we inserted the value of 2 inside the y-axis, so we have 1 copy other than the original one. And in the z-axis also we have 1 copy that is 20 meters above the original one because we inserted the spacing to be 20 meters. This is how you create a planar array. Now let's talk about the third type of array, which is the directional array. But first, let me start by creating a new rectangle in order to practice this array on. Now, in order to apply the array on this rectangle, you have to type down array CRV. Array CRV is abbreviation for array curve. So anything that you see has the abbreviation of CRV, it means curve. So now it is telling me to choose the object that I want to array. Then I have to choose a path curve. A path curve is any curve that is present inside the viewport. But now I don't have any curve path, so I will construct one and then repeat this command. For example, I want to have this path curve. So now I repeat the command of the array curve. So I type down array CRV. I choose the object that I want to array. This is my object. And then I choose a path curve. My path curve is this curve right here. Now I get like an option list. I have to choose the number of copies that I want to array. So if I want 2 copies, I type down 3 because the original object is counted in the copies. Or I choose the distance or the spacing between the copies. You could choose any option of those 2. You cannot choose both of them. So let's say I want to do 2 copies or 3 copies. Then you have to choose the orientation of the copies. You can either have them rotated, you can have them no rotation, you can have them in free form, and you can have them rod-like shape or in rod-like position. So let's start, for example, by having the no rotation option and with 3 copies. Now, as you can see, these are my copies of this one, and they are following the path of this curve. Now, let's try the same option, which is the directional array, but let's adjust the options inside the array. Let's say, for example, I want 4 items, which are 3 copies, and I want to choose the orientation to be rod-like. Now I have to choose the viewport. Since I'm working in the perspective viewport, I press anywhere inside this viewport. So now, as you can see, this path continues and did more rectangles. Now let's try the final option, which is the freeform. So let me type array CRV again. Choose the object to array. Choose the path curve, this one, and choose the freeform. Now you can see that the copies have random shapes, but still they are following the path. They are rotated and they are not having the same spacing because they are scattered freely inside the viewport. So this is everything related to the directional or the direction array. And this is everything related to the arrays. Let's move on to the chamfer section. In Rhino, there are several types of arrays, and I will be talking about them briefly. But in my opinion, I think that the 3 types that I talked about are the best because they have coordinates, they have reference, they have values. So they have some annotations in order to base your construction on, while these that I will be talking about them right now, they don't have any value, any coordinate to base your construction on. So it's basically creating an array, a free array inside this viewport. Let's try one option of this category. The first option is the array linear, where you have to choose the object you want to array, and then you choose the number of copies that you want. Let's say I want 2, and then you choose any point as a reference point inside the viewport. And then what will happen is that the 2 copies will appear inside the viewport, but you don't know where to put them, what's the distance between them, what's their position, what category they are. So they are just like shapes and copies of the object that you selected. So this is why I don't prefer to use these options. The second option is array curve on surface. Now, as you can see from the title of this array, array curve on surface. So I should have 2 components, a curve and a surface. So let me draw a surface before starting this command. Let's say also I have a curve on this surface because it is called array curve on surface. So let's say this is my curve on the surface. Now let us start the command. It's telling me to choose the object to array. Let's say this rectangle is my object. Then it is telling me to choose a base point. A base point is a reference point for the array. You can choose any point inside this viewport. I will be choosing, for example, the corner of the surface. Then you have to choose a curve on the surface, which is this one. Then you have to choose a surface. Now, as you can see, as I move the point on the curve that is on the surface, the array is changing. So all you have to do is to left click on the mouse and place those squares. And the limit is the surface. So I cannot exceed the corner of the surface, neither from here nor from here. So it's like limiting me from the extremities of the surface. Now, if I apply the same thing, but I choose a curve outside the surface, let's try it, curve on surface. Let's see what happens. So I want to choose the same object, let's say this one, and I want to choose the same base point, which is the corner of the surface. Now I have to choose a curve on the surface, but I don't want to choose a curve on the surface. I want to choose this curve. Now I want to select the surface. And as you can see, nothing happened. This is because the curve should be on the surface. So this is the second form of array that is free form. Now let's talk about the chamfer. What is chamfer? Chamfer is a super easy command, and it means that you have a sloped or angled edge inside your object. Let's take these 2 examples. You have the normal rectangle and you have the chamfered rectangle. The difference between the 2 is that in the normal rectangle you have 90-degree corners, you have sharp corners, while in the chamfered rectangle you don't have any sharp corners, you don't have any 90-degree corners, but you have a sloped or angled edge. Now let's apply the chamfer command inside the Rhino. Before I start applying the chamfer command, I have to draw some shapes inside the viewport. Let's say I want to chamfer a rectangle, I want to chamfer a circle, and I want to chamfer a triangle. Let's start by the first object, which is the rectangle. In order to start the chamfer command, you have to type down chamfer. Then Rhino is telling you to choose the first curve to chamfer. So you choose a side of this rectangle. Then you have to choose a second curve to chamfer. So you have to choose a second side of this rectangle. Now you can see that the corner is chamfered. Now let's try the other corner. I select the first curve, then I select the second curve, and now as you can see, the second corner is chamfered. Now let's try selecting opposite sides of the rectangle and see what happens. So I want to select this one as my first curve and this one as my second curve. Nothing happened, and in the command window it is telling me unable to find the closest intersection. So this means that the two curves that you are selecting should be consecutive to each other. Now let's try to chamfer the third corner. So I choose the first one, and before choosing the second one, you can change the distance of the chamfering. So you can put 10, and the second chamfer distance is 20. So now you can see that the cut is bigger because I made my distance bigger. So this is chamfering inside a rectangle. Now let's go to the circular shape. This circle is made up of several lines in order to create a circle. So I selected a random first curve, and now I would select the second curve. Let's say I want this one. Now you can see that what is left from the circle is this part. Now let's try chamfering this circle once again, but choosing different points on the circle. So I want, for example, my first curve to be this one, and when I want my second curve to be this part. So now you can see that a small part of the circle was chamfered. So in the circle, the farther the points from each other, the smaller the chamfer would be. Now let's go to the triangle and apply the chamfer. So I changed the distance. Now if you have your lines, the curves are not joined together, you change this one into yes and they will be joined. But since now all my shapes are joined together, there's no need to shift from no to yes. So now let's try chamfering the triangle. So I have to select the first curve and I have to select the second curve, and as you can see, the chamfer is created. Now as you can see, one part of the chamfer is higher than the other. This is because I selected the distance to be 10 by 20. But if I insert the values to be 20 and 20 for the second chamfer distance, you will see that it will be chamfered equally on both sides. So this is the meaning of chamfer, and this is everything about this video. Thank you so much for watching, and see you in the next videos. In this video, I will be talking about the last features available for lines. And these features are the blend and the adjust points. Now, as you recall from previous videos, I was unable to join a line and a circle, for example, or a line and a rectangle. This is because the line was an open curve and the circle was a closed curve. In order to join these two together, you have something called a blend, where you can blend two types of curves together. Either you can blend an open curve and a closed curve, you can blend two closed curves, and you can blend two open curves. Now let's try by blending an open curve and a closed curve and see what happens. The first thing to do is you have to type down blend CRV, meaning blend curve. Then you have to select the curves that you want to blend. So I want to select this line and I want to select this circle. Now, as you can see, there is a table that is appearing inside the viewport, and there is like some connection between the line and the curve, which is this one, which is a new line linking the two together. So this is the blending of these two lines together. Now you can adjust the options of the blending. So you have 2 points, you have point 1 and you have point 2. And you have like some options related to point 1 and point 2. For example, if you want point 1 to be tangent, you should switch the G4 into tangency. Now you can see that a point of these points is now tangent to the circle. You can make it curved. You can choose the position that you want. You can play with the anchors, as well as you can change the options for point 2 or the anchor number 2. You can make it tangent to, you can make it curved. You can set the position wherever you want. You can also have the option of trimming, the option of joining, and you can do whatever you want relating these 2 points. And you can still play with these points manually. So this is blending an open curve and a closed curve. So you can see that this is the blending of these two. Now let's try the blend command with 2 closed curves. So let's draw, for example, 2 circles and try to blend them and see what happens. So now I have to blend curve, these 2 curves. I have to select the curve 1 and I have to select the curve 2. So now you can see that there's a connection between these 2 curves. You can adjust the points on each curve wherever you want. You can move them. You can also choose the options that you want from this table, everything related to point 1 and everything related to point 2. And each point has its own anchors. So each option is different from the other one. For example, when you put the position button, you only have 2 control points, this one and this one. But you can still add some points by changing the settings of the points. For example, if you want more points to adjust, you can press either the curvature or the G3. So there are so many options you can do in order to create like a connection between the 2 curves. You can also flip the points, flip the directions of the points by choosing either flip 1 or flip 2. Now let's create a blend also using 2 closed curves. But this time I want to adjust the options inside the blend curve. So I would type blend CRV, and before choosing any curve I want to change the options that are present in the command prompt. So let's say, for example, I don't want to choose like the whole curve. I want to choose a point on this curve. So I press on this edge and change the option to point. So now I have to choose a point on the first curve and a point on the second curve in order to make a connection between the 2. So now you can see that I created this blend option using 2 points. But in this option, you can only change the options of point 2. You cannot play with point 1. You can choose so many other options such as blend start. You can choose, for example, a point. You can edit the curve that you created and so on. So this is everything related to blend. Now let's move to something really important inside Rhino in order to construct anything in 3D. And this command is called adjust points. Now, as you can recall, everything inside the viewport or everything related to 3D construction is based on lines. So you can say that surfaces are made of lines, meshes are made of lines, anything inside Rhino is made up of lines. So in order to adjust the form and the shape of the object that is made up of basically lines, you have to adjust the points of this line. Now, let's open the perspective viewport in order to understand what I'm talking about. Let's say you have this curve, for example, or this curve. Now you can notice that this curve is in 2D. It is in one single plane. Now when you press on this line or curve, you can see that this curve is made up of 1, 2, 3 points. Now in order to make this line in different planes, you should adjust the points of this line. Now in order to adjust the points of this line, you have 2 ways. You either use the gumball or you type down move and move each point by itself. Let's try, for example, moving this point right here. What I have to do is that I have to select the line or the curve, then I have to select the point that I want to adjust in this curve. So I selected this line at first in order to identify my points. And then, for example, I want to change the the position of this point, this particular point, I click on it. Then in the selection menu, I have like a small menu. I select the curve point. Now my gumball is on this point. Now you can use the arrows of this gumball to adjust location and position of this point. For example, you want to keep this point in the same plane, but you want to move it away a bit, so you use the green arrow or the arrow responsible for the y-axis. If you want to move it in the x-axis, you'll use the arrow that is responsible for the x-axis. So you'll use the arrow responsible for the x-axis. Now, if you want to change the height of this point, you will work on the z-axis. And now if you change the point, this line won't be in the same plane. Now you can see that this line is becoming outside the plane, so it's elevated. And this is the main step in order to construct a 3D object, having points in different planes. Now let's do the same option of elevation, but using the move command. So the same thing that you do is that you select the line or curve that you want to adjust points in it. Then you select the point that you want to adjust. Let's say I want to adjust this point. You type move, and then you move this point from this level to the level that you want. And now you can see I'm moving my point freely inside the viewport. But this move command won't elevate the lines or the curves. This is because when you move the point, let's say I want to choose this point again and move it, you are choosing a horizontal point inside the viewport. So this object automatically will be in the horizontal plane, which is the X and Y. And this is why you don't have any elevations. Now, in order to have elevations, you have to make sure that when you choose the point, you should have the vertical option turned as yes. So now when you move the point, it will be moved in a vertical position and creating this elevation that you want in order to create a 3D object. So when you want to elevate a certain curve, you have to switch this option into vertical, and then you have the option to make it elevated. So this is everything related to blending and adjusting points inside a line. Thank you for watching this video.
Hi again! Congratulations on completing this 6.5-hour Rhino 3D tutorial. It's a big achievement and I hope that you have enjoyed it. You are now ready to start creating some amazing stuff. If you would like to uncover all the hidden tricks, tips, and unique styles of working with Rhino, go check out the full course on skillademia.com. The beginner to advanced course consists of many more exercises which will turn you into a pro in no time. You'll be able to learn everything you need to know about improving your 3D designs and complete many more projects, making you a Rhino design master. If this sounds like something you want, go check us out. Thank you for watching and see you soon.